Hey, this is definitive course on AI agents for software engineers. I've been a software engineer for over 6 years, I've been coding for way more than 10 years, and now I'm running my own business teaching people how to become software engineers. To follow this course, you need to know how to code, okay, because this is obviously for developers, but we will go deep into AI agents, we will leave out all the hype, and we will actually understand how AI agents work, and we will build something like Claude Code. So here's what we actually gonna learn, okay? We're gonna learn the difference between agents and AI workflows, okay? And we're gonna go deep on the workflows because despite the name, it is actually a pretty important thing. We're gonna learn all of those AI workflows like Augmented LLM, prompt chaining, routing, parallelization, Orchestration-worker, blah, blah, blah. We're gonna have a look at the main agents and how to use them at Claude Code, Codex, and Gemini. But by the time you're here, you will already understand so much about agents, okay? Then we will have a look at the basics of those agents, how they're actually built. So first we're gonna use those agents, we're gonna have a look how you can apply them in real systems, and then we're gonna have a look how they're actually built, and we're gonna actually build our own agent, okay? So something like Claude Code or Codex or whatever you use, we're gonna build it, right? So we're gonna understand agentic loops, how to use tools with the agents, loop tool calling, self-improving agents like, for example, PI agents, one of my favorite topics that I think is going to be kind of the future of agentic AI engineering, okay? We're going to have a look at the popular SDKs, which will be OpenAI SDK. We're going to have a look how it works. We're going to have a look at things, how we can orchestrate multiple agents and different patterns of agentic behavior like handoff or human in the loop. So let's actually get started, okay? There's so much hype around those AI agents and all these things, but when you zoom in on those videos, and this is what I get recommended all the time on my YouTube, you will see that behind it is actually not a freaking agent, but more of a workflow, right? So this is more of kind of like a workflow. And this is what so many non-developers don't understand, that what they're trying to call an agent is actually not so much of an agentic behavior, right? I see it all the time in my YouTube, is that, oh, AI agents. No, guys, you're basically what you're doing here is that you're creating workflows, right? The same linear thing that we had for such a long time in software engineering, and you just discovered it, and you put an AI layer, an LLM layer on top, and then you think that this makes somehow everything agentic. It doesn't. It is just a workflow, okay? And that's the first thing that I want to kind of cover, okay? The difference between those workflows and agents. And even though I kind of dismissed it a little bit now here, but actually workflows are pretty important. Once you understand the workflows, you will understand also kind of the agents, okay? Workflows, they're important in the way that they stay approximately the same. So agents started, I think, around 2022-23, right? So those agents as what we understand right now under agents, right? Like Claude Code, Codex, and all this type of things. They started around 2022. And only now they got popular, right? Only 2025, 2026, they actually got way more popular. I think Claude Code was developed around here by the end of 2024. So they have been there for a while. And those workflows, they have been there for even longer. And if you understand those workflows, you will understand more than probably 99% of all people about AI engineering. And everything that is here is actually pretty simple to understand. So I'll explain you everything, okay? Before we go there, I will heavily follow the guide from Anthropic. So if you wanna also read kind of the main paper of this whole AI agentic engineering, I will attach the link in the description. If there are no link, just write the comments if I forget. Okay, so one of the important things that Anthropic said back then is that they always recommend to find the simplest solution possible. And this is very important for us software engineers to understand, that not everything has to be an agent. It is very good right now to basically say, oh, AI agents this, AI agents that, right? And I totally get it. AI agents is the next big thing. AI agents are gonna be huge over the next 10 years. I'm highly convinced about this. But we should not overcomplicate it. Okay? If a workflow doesn't need an agent, then it doesn't need a freaking agent. And if we can solve it with just normal code, what we used to do, then we should just solve it with the normal code. There's no point in putting agents or putting AI where it doesn't belong, where it just makes stuff complicated. And I see this this so many times with different companies that they are trying to put agents where they don't belong. And I personally worked at the companies where they discovered this whole AI thing and they started saying, oh yeah, we're gonna go AI, we're gonna do this, that. And I'm like, but what's wrong with the way we've been doing it? There's nothing broken. There's no point in modifying this. The same goes for you as an engineer, right? So when you see something that can be solved just the normal way we used to solve stuff, well, we can keep it this way, okay? So this is what Anthropic also says. Anthropic says, okay, guys, agentic systems, they trade latency and cost for better task performance, okay? And you should consider whether this trade-off makes sense, as in a lot of cases in software engineering, everything is a trade-off. Okay, so basically the complexity, okay, the complexity of these workflows, it grows as we gonna progress through them. And the first workflow is this augmented LLM. Now, this is not even not even something that we should be covering, because augmented LLM is just basically means that this is an LLM system. You send something in and you get something out. And while you send something in, it can do retrieval, it can do tools, it can do memory. Okay, so we will build a bunch of those things from scratch later. But essentially, in a lot of cases, this first pattern, it is already baked into the LLM. Right? So basically this pattern, we can just kind of say, okay, it's there. So now let's actually start building. And the first thing is how we're actually going to build. Now I'm going to be building everything with a TypeScript, And this whole AI engineering world is divided between TypeScript and Python. So you need to know one of them, either this one or this one, okay, to follow this tutorial. If you know any of them, that's good. If you know Python and if you're not a TypeScript guy, okay, or girl, okay, you can follow that still. I personally, I'm a TypeScript developer, so I will be following the TypeScript because I'm coming from Salesforce background, okay? So now let's go here. The first thing that you need is that you need to have packages. Yeah, you need to have the packages. Oh my god, where's the packages? You need to install the dependencies. I'm gonna again attach everything that you need to install. Basically, what I'm gonna do is that I'm gonna use OpenAI API key. Okay, so I'm gonna use the OpenAI API, not API key, also API key, but I'm gonna be using OpenAI API. The reason why I'm using OpenAI and not Anthropic, for example, is because I personally find it very easy to work with the OpenAI API. It is very descriptive, it is very nice. Versus Anthropic is sometimes a little bit confusing for me. Like, I don't think that I have the best API, but it's also it's a good API. Okay, it's a good API. You can use it either with Anthropic API or with the OpenAI API. If you're the Google person with all the Gemini stuff, I don't recommend you. At this point, OpenAI and Anthropic are just way ahead of Google when it comes to API and agentic development. So I recommend you using either OpenAI or using Anthropic. Now, the way you do it is that you go here to the OpenAI API. Okay, that's where you go. You go to the API platform. You log in into the API platform, not into ChatGPT. You log in into the API platform, and you go to the API keys. And I'm gonna show you all my API keys so you can steal them. And then you click here on create new secret key, and then you put whatever secret key you want. Okay, so you do that, and then you go to the env, and you can see here my all real API key for everything. You can steal them, take as much as you want, free credits for everyone. No, I'm joking. I'm gonna rotate the keys after the video. Don't worry. So those keys gonna be irrelevant anyway. But you can see I have here OpenAI API key either in the .env, and that should be fine to follow this whole course. Then the next thing you need to do is you need just to simply install these packages. If you're using npm, if you're using bun, it's fine, use whatever you want. You just need to install OpenAI .env and tsx. Okay, this is if you're following the TypeScript. If you're following Python, then you can use the super cool UV, whatever you're using for installing packages and dependencies, just use it. Okay, so you need to run it, and then in the package JSON, because it's very convenient for me, I just created those shortcuts so I can just easily run those scripts out of my parent folder. That's just the way I like it. Okay, so now if you think that you set up everything correctly, which is just one freaking command, so it should be working, then this whole thing here should be working for you too, okay? So I'm gonna explain everything that is going on here, but for now, if this thing works for you, then this is good, okay? So you need to open the terminal, make it a bit smaller, and I'm gonna run this thing here. So I'm gonna say npm run, and then I'm gonna put there the get started, okay? Get started, like this. And I'm sending ping, and I'm receiving freaking pong. It means it's working, okay? So it's all working. Now, I'm gonna clear because I hate having my terminal, anything in the terminal. If you have this one, it means the connection is working. It means you installed everything correctly, okay? So let's actually go and have a look at the first pattern, okay? And the way we're gonna do is that I'm gonna give you actual real-world scenarios where you might be using those AI workflows, okay? So let's first have a look. Let's go back. Let's go back to my beautiful drawings here. Let's have a look at the first pattern, okay? The first pattern is called prompt chaining. Now, why do we need it, right? Why don't we just dive immediately into Codex and Claude Code and all this type of things? Well, because the best way to actually understand something is to build it yourself. Okay, this is literally the best way. And I don't mean that you're going to be building those things from scratch all the time. But trust me, once you understand those workflows, and there are only 5 workflows that you need to understand, once you understand them, all these agentic patterns will be so much easier for you. All this building AI agents and all this hype around them will be way more clear for you, okay? So you'll understand it way better. So first, we need to understand those workflows. Which workflows doesn't mean that this is freaking AI agent. So let's have a look at this. Let's have a look what's going on there. Prompt chaining. So what's the freaking prompt chaining? Basically, what it means is that we have a bunch of prompts and we chain them together, obviously, right? Now, this is the diagram that here it means that the user sends some kind of input. User can be, for example, can be you or me, right? Which usually means a developer when we are speaking about AI agents. Can be also an actual user, right? So it can be another user depending what kind of agentic system you're building. Doesn't matter. In some way, your LLM or your code gets some input. And with this prompt chaining, we're gonna call an LLM. Now, what we are trying to build here is that imagine you're working at a large corporation. You're working at the freaking Coca-Cola, okay? And you have existing code base with tests that already run. This is very frequent what I used to have all the time. So imagine you have a huge code base, right? You have one, two, three, four. You have whatever gazillion different tests that are running. And whenever you deliver anything into production, right? So you have production and you want to deliver anything in there, you need to make sure that obviously all the other tests that you already have in your org, that you already have in your code base, they're still running, right? It would be kind of bad if you delivered and then suddenly only 30 tests out of 100 that used to run are running, right? No, it means you broke something that has been working before, right? So this is a very common thing. And what you usually do is that you need to run those tests every time you deploy something or every time you develop something. Now, the scenario that we have here is that we have this code base and we want to add the new feature by prompting LM the code, right? So we say, hey, Claude Code, go and actually do some new feature, okay? But at the same time, we want to make sure that Claude doesn't actually, or any kind of LM that you have, doesn't actually break anything, okay? And we also want to make sure that we generate some kind of change log, okay? Now, how would you do that? You could, for example, the most naive way of doing that is just going to Claude and saying, yo, Claude, can you please don't break anything? Don't break production. Hey, Claude, please, can you not break production? Can you don't delete the whole database and all the customers? That would be one way of doing that. But this is not good enough because you want to make sure that the agents that you're developing, they're not going and doing crazy stuff, but instead you want to have some kind of gate. Here it is. This is the gate. This gate basically says that, hey, LM, this is nice that you created an output. Now let me actually programmatically check that you can proceed. So instead of just giving your agent a whole, basically just, hey, you go and do whatever you want as much as you want, right? Instead of doing that, what you do is that you say, hey, LLM, do this, and then you stop the LLM programmatically. So there's no way for LLM to somehow avoid it. No, LLM call stopped. Then you programmatically run the checks, and only if those checks work, you keep going with the next prompt, and then with the next prompt. Now, the most important part here is those gates here. You create the gate, and then your LLM has to pass the gate in order to proceed with the next input. Okay? So this is very important part to understand. So let's have a look how it actually looks in the code, right? So first of all, if you're not familiar with the TypeScript, you're still gonna be able to follow everything I'm showing you, because code here is so primitive that even if you're a complete beginner in coding, you're still gonna be able to understand all of that, okay? Just look, it's less than 60 lines of code. It's 56 lines of code, okay? Of TypeScript, including console.log. So if you understand at least a little bit of coding, you will be able to follow this, okay? It is that simple, especially if you're a TypeScript developer. Well, it's going to be easy for you. Hey, I know you've been watching the video, but I'm interrupting you to say that you can download all the code in the link for free, and you can just use this code. So if you want to follow a little bit easier than trying to retype everything from the video, then you can just use the link below, okay? Thank you. Now let's go back to the main thing that we've been covering. Let's keep going. So the first thing is that, of course, we import the client from OpenAI, right? We are importing the package so we can make the callouts easily. We don't need to write everything on our own. Then the next thing, we have here 3 files. We have products, and let me actually delete this one. Let me delete this one because this is what we want to have, right? So what we have an existing code base. Let me just commit this one. Products done. Okay, so this came from the testing. Okay, so we have products here. This is our existing code base. Okay, so we already have something in there. Doesn't matter what, really doesn't matter. Again, all the files you can download in the description. Doesn't matter what, but there is some existing code base, and there are some tests. Okay, very primitive tests, but there are some tests. And when you run this chain.ts, what you want to make sure that your LM actually passes all the tests before it proceeds to the next step. So the first step is that we need to generate new code, okay? Can be any kind of step. It doesn't have to be that we generate a new code. Can be, for example, that you're writing a blog post or anything, and then your LM call is generate an article, okay? And then your gate is to verify some kind of, I don't know, quality checks. Doesn't matter. But in this case, we are following this scenario, right? So now, The way we make the call is that we just say client response create, and then we put the model that we want to use. I'm using 5.2, and we put an input as a prompt, and then we append the code that we have, right? So we imported the code from the file, from the products.ts. Then we obviously have the response. And now this is the most important thing. Now this is why I'm showing you this. We have an actual programmatic check, just a simple if statement that checks that the gate, that the code has this function. Okay, so we are asking the LLM to generate this get cheapest function, and then the first check for us is to actually check that the LLM output actually contains this function. This is the first gate that we have. And if it is not passed, then we programmatically stop the execution of our workflow. And this is important to understand. Because if it was a completely this whole AI agent that has a complete autonomy, then there would be no programmatic verification in what this agent does. But in this case, because we are writing this everything from scratch, right? We are writing basically our own LLM calls, right? In this case, we can programmatically control how our workflow is executing. So in this case, we say, okay, if the new code doesn't include the get cheapest as a function, then the gate number 1 is failing. Okay. Now, if it does include, then, okay, gate number 1 has passed. Now, we write the code back into products.ts, okay? We write the new code. So we are proceeding to the next prompt, to the next step of this whole agentic workflow. Now, once we wrote it, we execute the tests, and you see that we do it programmatically, right? So we are not telling our LLM to execute it. And this is a big difference. This is very important to understand. We are executing tests programmatically. And then if they work, then they work, and we say, okay, gate 2 passed. If no, then again, we are exiting, okay? We are catching the error and then we are exiting it, okay? And then when this gate has passed, we generate a changelog entry, okay? Then we put it, and then we put it out in the changelog. So, okay, let me code. So it's gonna be npm run, and it's gonna be chain. Yeah, I always make this typo, always nom instead of npm. Run chain, okay? Now it's running, okay? Well, you can see that first was gate 1, then gate 2, then we run the tests, then all tests passed, right? And then we have the changelog. And you can see that we have a new changelog here, right? So we have the changelog entry in there. Now, if we visualize it, it looks in this way. So we have an LLM call, generate code, then we go to the first gate, and then we check, okay, what was the what was the first freaking check? The first check. Let me make it like this. We check that the function is there, right? So yeah, we check that the function is there. Is the function in there? If no, then we immediately fail. Okay, we immediately fail. Then we run immediately another check. We run the tests, right? And then if everything is good, we make the changelog. So this is important difference, okay? So we are creating here an agentic workflow. By no means, this is not an agent, right? Like, this is not a thing that like is general purpose, that can go and whatever, you can ask it, hey, can you plan for me a dinner, and then it's gonna go and make a reservation, and then you can say, hey, can you create for me this beautiful Next.js application, then it's gonna go do that. It is not an agent in this sense. It is an agent in the sense that it chains a bunch of action after each other. And this is the difference between agents and workflows, right? Workflows, you kind of chain the actions, and they do behave kind of agentic way, but they're not exactly the agents what you would imagine. Okay, so that's the first workflow, and you see it is incredibly easy, right? So with all my comments on all of this, it's like 50 lines of code. But I hope that you get the idea of this prompt chaining, right? Now, why is it important? What could be your application in real world, right? In real world, everywhere where you want programmatically make sure that certain action occurs, you need to have those gates. This is what people don't understand. That if you have, for example, this is I'll tell you what I have in my business, okay? In my own business, what I have is that I have a database. And I have a website. It's called learnapex.com. And in this database, there is a bunch of, like, really a lot of tasks. So this is essentially a database that tasks that allows you to learn how to code on Salesforce, right? On Salesforce. Doesn't matter the details. I just want to show you the agentic workflow I have. Now, I also have obviously an LLM that sometimes people send me feedback to another form. Okay. Oh, my writing is very bad today. What the hell is that? Let me make it like this. Let me delete all of this. Let me make it better. Okay, so this is database, right? Then I have an LLM. Now, this is a live database. Would I just allow my LLM to commit whatever data I want into this database? No, it would be stupid. It would be really, really stupid. I did it, okay? I did it a couple of times. It messed up a few things in the database. Not critical, but I tell you I did it. I did this mistake. Don't do this mistake. Don't repeat. Learn on my mistakes. Now, I don't allow to do that. I have a gate here. Gate that blocks writing into everything except what is manually allowed. So for example, you can only write in the tasks. Okay, you can only write in the tasks database, in the tasks entries. Okay, and this is just a Python script. Okay, this is just a Python script that blocks LLM from writing into the database. And then this Python script, on top of that, it also runs checks on the quality, right? So I defined the quality criteria that we need to have before we can write into database. And this is the way you should think about those things. You need to include, when you're building some kind of agentic systems for production, for your clients, for in general on your work, you need to think about the gates that's going to prevent LLM from messing stuff up. You need to think about this. If you're not thinking about this, then it's it's not gonna end up well. Okay, those LLMs, they can mess up a bunch of things. They're very smart. So, like, one thing that you cannot do is that you cannot rely on just telling an LLM, hey, you know what? Can you just not write into database? Can you not delete my database, please? You cannot do that. You need to have actual programmatic checks that will prevent it from doing that. And this is a very good example of a simplest possible programmatic check, okay? So here you literally you just make an LLM callout, okay? And then you just have an if statement and you exit the program if something's wrong. Okay, so the next thing is routing. Let's have a look at the routing. Okay. Now, routing is a fun one because this is variation of this workflow you will see in a lot of different cases, okay? In many, many, many different cases. The most common scenario for here is basically this one, a support system. So imagine you're building something and you're building some kind of support system for the customers, right? Customer sends a message, okay? And we need to see, so we have a message. And then we need to see where to forward this message. Okay, we need to see where to go. Is it the billing or is it a tech question? Okay, so billing, tech questions, whatever. So we need to understand what kind of what kind of intent does the user have, and maybe sometimes we also want to actually forward to actual person, right? Person here. So we need to understand what kind of intent the user has, and then we forward to this type of specialized LM call. Okay, so for example, each handler has completely different system prompt. Okay, so for example, one handler can handle refunds, another has technical, and another one just a general one, or maybe another one is an actual human, right? So this is one of the very popular workflows that you will see, because sometimes you start chatting with like a chatbot, and then you say, hey, can I actually speak to the human, and they will forward you to the human, right? The same goes for the billing, for example. Is they say, hey, can I get a refund? That should go into a different agent or a different workflow in comparison to, hey, can you explain me why I cannot turn on my computer, or something like this, right? Now, here's what's important to know about this. Agent is not required for this, okay? If you have one general purpose agent, or if you try to fit into this scenario one general purpose agent that's gonna just do whatever, then you're gonna run into a couple of problems. First, you're gonna really mess up your context. Remember, the context window right now for really good models is 200k or 1 million. Okay, so at the moment where I'm recording this is approximately what you need to count on the context window, and this is for everything, for reasoning, for all the tools you're calling, for everything. And if you have 200k, sure, it's enough for some things, but it's not like you can just waste this context completely, especially if you have tools, if you have all this type of things. So you need to be aware of the context management. Yeah, so if you're gonna try to do this, we have in, we have out, and then we have one agent, and this one agent has a system prompt, has refund API, invoice, bug, error, FAQ, hours API, right? So we load a bunch of tools into one agent, and we just say, hey, you're a chatbot and you're tasked to deal with all the tools. Now, this might work for simple stuff, but what if you have 50 tools? Okay, what if you have 50 tools? What if you have 250 tools? Okay, you're gonna have to preload a bunch of things into basic into system prompt, into this agent, and it's just too much. You're just gonna completely destroy the context window. So instead of doing all of that, you need to have the classifier, not the classifier from machine learning, but actually an LLM that's gonna have a look at the message, and it's gonna just forward to the right tool. Okay, and now you kind of decouple this thing. You make it more modular, right? You separate in different modules, and now you can have as many as you want, right? Now to add each additional module is just one additional call, which is super easy for the classifier agent. Okay, so now each individual agent is not overflown with different tools, and this agent is actually pretty lightweight. Or I tell agent, I mean just an LM call for this case. And also, you kind of reduce the risk, because, for example, if you try to put everything into one agent, that what could happen is that you might have some leaks, right? So, for example, someone is actually gonna try to hijack, I don't know, your billing API or whatever, or gonna try to get a refund at the same time, try to kind of find the bugs, whatever. So if your tool has access to the hours API and bug tracker and invoicing, right, then there might be a little bit of overlap in terms of people might try to hijack a little bit. So this is not a good approach, and instead you need to build this kind of classifier. And you can see it's a pretty easy concept, right? So it's kind of like it's it's similar what we had in software engineering for a very long time. It is just that you add an intelligence level on top of it, and this intelligence allows you to basically build it a little bit more robust, right? Because how would we build those systems before? Because we had those systems before, right? You would make some kind of semantic analysis, right? You would make something like, for example, the most primitive way of doing that. You would have search for different catchphrases for different like words. Okay, if it has a word invoice, it goes to the invoicing. If it has technical, it goes to the technical. And if I don't know, it just goes into the other category, right? To the human. This is the most primitive way. Now you can remove those inefficiencies. But essentially, this is still kind of the same layer, right? It's kind of the same idea. It's just that you add intelligence on top of that. Okay? So, yeah, so the reason why we have those multiple LM calls instead of just one big is because we want to increase security. We want to separate the concerns. We don't want to have too many dependencies. So we make it all pretty neat, right? So this is how it looks like. Let's have a look at the code. Let's go here to the routing. Okay, so I have a couple of examples here. I have a simple routing and I have then a little bit more of a complex routing. Okay. So here a customer sends a message. The first LM call separates this into the right. You cannot read everything. Okay, here it is. So it separates into the right route and sends it to the specialized LM. Now here I just simulated. Okay, here I just said, okay, let's imagine that this is the customer message, right? And in the next one, I'm gonna show you how the code looks like for not simulating, actually talking. Okay, so customer says, I was charged twice for my last order and I need a refund. Now, what you do is that you just make a call out to LLM. That's all you do. You just make a call out, okay? You just make a call out. You say, hey, classify this and return only one word. They're usually pretty good at following this, okay? And then you append the message. That's it. And you're literally gonna get here a classifier, okay? You got your classification, and then you just basically create here an object, and you say, okay, for billing, this is my prompt. For a technical agent, this is my prompt, and for the general callout, this is my prompt. Okay, so it's very easy. So again, nothing crazy. One LM callout, then just getting the category in the proper formatting. This is another line. Then we're just creating prompts. Okay, so this is basically creating an object. And now we get another LM call here, right? With the instructions. What kind of instructions? Well, instructions depend what was the classifier before, where did we classify it. And then the next one is the customer message, right? So we put the input of a customer message in there. Easy. You see, with all this type of things, less than 50 lines of code. Let's run it. So it's gonna be router simple, I think. Yeah. Clear. Router simple. Let's run it. Okay. Well, it says that it's billing. Okay, I need refund and routing to billing, and then it continues with some kind of messaging. And again, you can combine this pattern with the previous pattern where you have some kind of gates. For example, for a tech support, I would say there's not that many gates that you would need, but for the billing, well, you might want to have a little bit more gates, right? You want to have check something, you want to programmatically stop LM before it's going to do anything and actually make the proper call out or an if check. Yeah, so that's the way you do it. Now let's change this one. Let's change the message, right? So let's say I was charged twice. Let's say I can't turn on my device after the last update. Okay, it was working fine yesterday. Now we're gonna run the same thing, and now it's gonna classify it into the technical, right? So you can see that those classifications, basically what it allows us is, as since we brought this whole intelligence layer on top of that, it allows us to easily classify all of this and to build those systems way more intelligent. Now it thinks, and then it gives some kind of response. Now, here's the question, is it an agent? Not really, right? It doesn't actually do anything. It's just a smart chatbot. What we had for so many years, at least for 10 years, we had those type of things. It's just that right now they're very sophisticated, okay? But you will see that this whole routing idea is gonna come alive once we discuss agents, right? Because as I promised you, we are covering all of this in order to understand agents. Now I have another example. So I have here, I'm not gonna go over code too much. Again, all the code, you can just find it in the description. So I don't know, maybe I'm gonna put it on the GitHub. Let's see. Anyway, so it's exactly the same thing. Now, the only thing is that we actually speak to the user, okay? So I'm gonna just go with the router and here, customer. So you're a customer, right? So you're gonna say, what am I gonna say? I'm gonna say, hey, I am hungry. Classified as general, which is correct, right? So I'm hungry is definitely not one of the tickets. And it says general, want something quick for a full meal. Okay, so you see, this is one of those examples. I'm gonna show you how to deal with those things, where, for example, in this case, I actually don't want my agent to even engage with anything. Okay, so in this case, what you could, for example, have is a gate that will say, okay, for general, we're gonna stop. Okay, for general, we're gonna forward you to an actual person. Okay, let's not say, hey, I actually can't turn on my device, can you help? Okay, and see, it's classified as technical now. So again, this is just a demonstration. By no means I'm trying to create here like live production systems. Let's exit this thing. But the idea is to show you this routing approach, right? So we use intelligence to understand where to route it. Let's go this here or here, and then we finish here, okay? Yeah, so that's the way it works. It's a very simple, and yet this is something that you'll see in a lot of different systems because this is just a nice way of creating those AI workflows. The next one is actually a pretty fun one, and this is called parallelization. Now, we're going into a little bit more of an advanced part, and this is where it gets quite interesting in my opinion. Because here we have two different patterns when it comes to parallelization. We have voting and we have sectioning. So first, let's start with the voting. Let's say you're building something like this, right? So you're building a content moderation system. This content moderation system basically is going to see if this review is correct. Now, you could achieve it different ways. You could achieve, for example, you could do it by having one agent that's just gonna do all of that. But you can also separate it into different criteria and then run the checks separately. Now, this example here is somewhat artificial because here you cannot really see the full power of parallelization, because usually you use parallelization when you have kind of a big of a research to do, kind of a something that is long running. Okay, in this case, this is just a really good example to show you the voting pattern and how it can be applied, but it is not something you would use in exact the same way. So look at this. So you have this review. This product is very bad. The seller is scammer from China. And his email is john@scam.com. Don't buy this trash. Okay, so this is the review that you get. And now you want to understand, okay, should I actually post this review, right? You want to have an intelligent overview over your posting system. And what you do is that you run 3 checks in parallel. Why not sequentially? Well, you could run it sequentially, right? But that would be a different pattern. That would be not the parallelization, right? If you wanted to run it sequentially, well, maybe you could do something like prompt chaining, right? With different gates. Maybe if you fail one check, then there's no point in doing other checks. But in this case, we actually want to kind of have a consensus, right? We want to have kind of a majority voting, because maybe it is a little bit offensive, the the message, but it is not that offensive, okay? Maybe you can survive by posting this review. Now, what we do here is that we have 3 different, make it like this so you can see a bit more. So we have 3 different LLM calls. So we have the first one that checks for the hate speech. Then we have another one that checks for the spam and manipulation. And then another one that checks for the personal information. Okay, we run it, and then we get their votes. Yeah, and then we say, okay, if we have 2 out of 3 or 3 out of 3 say that this is fine, then we can post it. If majority decides that this is not fine, then we don't post this review. Okay, so that's essentially the whole code, right? So we search for unsafe, and then we see if there are more than 2 unsafe, well, then it's blocked. Okay, that's what we do. So let's run it. We're gonna run voting, okay? And we run 3 in parallel. And you can see that hate speech unsafe, spam unsafe, and personal information is also unsafe. So 3 out of 3 said it's unsafe, okay? If I say, for example, here, if I try to say this product is very good, right? And then I'm gonna run the voting, well, then it's still gonna be not safe to post. And this is the whole benefit of those LLMs. They're smart, right? You won't be able to do that before LLMs, right? It would be hard to do, because here we have kind of mixed signals, right? At the same time, the user is trying to say, yeah, the product is very good, but the seller is the scammer. So we actually need to have this intelligence layer on top of our system to understand if this is a proper review. Now, if we remove here, what should we remove? Personal information, right? So from China, here we go, and don't buy this trash. Okay, so let's run the voting again, and let's see. So see, now personal information says that this is a safe review, but all the others, they say it's not. So we still don't post it. Well, let's try to do don't buy this. Okay, now should be fine. Okay, spam unsafe. I don't know why it's still unsafe, but you see, even though spam says unsafe, the 2 others says, okay, it's pretty safe, and we publish. So now the benefit of it is that we run all these checks in parallel, so you see that they are finishing pretty fast, and then relatively quick we have a bunch of, we have a vote and we have the understanding. So this is a good thing where you can actually run some really good voting, where you can vote on something. Now, where I would not run this is that I would not run it, for example, on something that has some artificial metrics, like, for example, code quality. Or I'm gonna run 5 agents and they're gonna rank my code on a code quality metric from 1 to 10, where 1 means it's a trash and 10 means it's gold. And then we're gonna, whatever, if it's more than 7, then we're gonna pass the code review or whatever. So this is an example of something that is artificial and that you should not kind of run. It works well where you can assign an actual score. Like, for example, this customer satisfaction thing, right? So customer satisfaction. Customer satisfaction, right? So if you have some kind of whatever customer satisfaction, and then you get a bunch of different votes there, then you can then you can analyze them, and then you can have some kind of score at the end, and then you can do something with that score. Doesn't matter. The point is that you need to have something that is quantifiable and that can have some kind of voting, and usually that means that you can somehow assign a number to this, right? Now, another thing that we have is the sectioning, and this is also an interesting parallelization pattern, and this is actually used quite a bit. The way it is used is that you already have seen it so many times, and you probably have used the feature which is called deep research. Deep research, right? Deep research basically means that you're asking LM to research a topic, and then what it does is that it starts running a bunch of different queries in parallel. Example, AI for coding. AI for coding. You say to your LM, hey, we need to create a blog post about AI for coding. And what happens is that it starts in parallel searching for a business impact, right? Business, whatever business. Then for developers, then it analyzes jobs, whatever. So it analyzes a bunch of different things, right? Now, in this case, we kind of pre-code what kind of... So look, in this case, we have the LLM here, we have LM here, and we have LM here, but we don't have LM here, okay? This is important. Otherwise, it's going to be a different pattern, the next one that I'm going to show you, okay? But in this case, we just distill a problem into different steps, then we execute those steps in parallel, and then we just put them together. So concrete in the code, it looks like this. So we have a topic, AI coding agents, right? And we are researching 3 tasks in parallel. And by the way, it works well if you have different LLMs. So for example, you can have Gemini, you can have Claude, and you can have OpenAI, and they all research it in their own way, and then you combine them, right? Now, in this case, we send the first one with the web research tool, and we say research the technical architecture of AI agents, right? How do they work? Blah, blah, blah. Then we say, okay, research the business case of blah, blah, blah. And then we say research the risks and the critics of the topic of AI agents. And now we combine them. And important that we are combining them not with the LM, right? So this is what I wrote here. The reason for that is because that if we use LM, that would be another pattern, right? So this is simple. Again, this is not the idea of trying to orchestrate different LMs or different agents. This is the idea of trying to distill one task into 3 different steps. If you, for example, if you in advance, if you know that your blog post writing is always those 3 steps, then you can run them in parallel and then do them. Okay, so again, this is you're designing AI agents. You're not using AI agents, right? You're just, the only thing that you do is that you just basically call an LLM here. That's all you do. So let's run it. Let's run it actually. So that's gonna be run sectioning. Yeah. Okay, you can see it says running 3 research tasks in parallel. And well, now it's running them. Okay, so we have to wait until it finishes. Oh, all right, a bunch of things. Right, so now we have another file here, research.md, and you can see that it researched a bunch of things. Technical architecture, business use cases, right? It even put some links, which is pretty cool. Okay, and then it has this, what, risks and criticism. So this is basically the way to do this, to run something in parallel. Now the problem with this pattern, and I hope that you see it by this time, is that the distribution of the tasks is essentially hard-coded here. So if we go sectioning, here we go. It is essentially just hard-coded here what kind of steps are we using. And this is not exactly what you want to have, because in a lot of cases you don't know in advance what will be the steps, right? You're like, okay, I know that my writing process, it is those 3 steps, but I don't know what kind of topics are going to be, right? I cannot just hard code all the time. I want to have it dynamically. And that's why we have the next pattern. Okay, this is why I have the next pattern. And this is Orchestrator-workers. That's the next pattern of this AI workflows. So this pattern is essentially the same thing as the last one with the parallelization. Now the only difference is that we have an orchestrator here, which kind of actually does the separation of the tasks. And then we have the synthesizer, which actually does the synthesize the results of this parallel execution. So essentially it's exactly as the last thing. It's just that we are adding one layer here of an LLM of intelligence, and then we add another layer of LLM and intelligence after to synthesize the results. And that allows us to make it more dynamic. So for example, what happens if I want to have a post about AI agents, right? My approach probably will be research, then I don't know, like think, then write, then yeah, research a bunch of topics. Yeah, that would be research a bunch of topics, then think about them, then write, then I don't know, like check everything, right? So that would be my steps. Now this research can be done in parallel, right? I can just say, okay, there's topic number 1, 2, and 3, and I can just distill this task into multiple different steps, and then I can run this research, and it can actually research everything. Now, the thing is that now, using the same approach, the same kind of patterns, we can also write a blog post about starting an AI company or about Claude Code, right? So we apply the same pattern, the same workflow on multiple different blog posts. Versus with the previous one, we actually had hard-coded all the steps. Again, there's a time for one, there's time for another. You see how the complexity increases, right? You can see that this is a very simple workflow, and this also has a place in case we don't need this additional layer of intelligence, and you don't need it all the time. And this is where, for the first time, we're kind of going a little bit into the agentic behavior of those systems, because now it's about orchestrating a bunch of different LLM calls and then synthesizing them, okay? So the way we're gonna do it here is that we have an orchestrator, which is LLM, as I said. We ask this LLM to break our topic into different sections, and LLM decides how many sections, what kind of sections, and all of this, okay? Then it spawns a bunch of different workers, like 3 workers, and then it goes back into an LLM, and another LLM call combines all of that into one coherent piece of blog post. And you see that this approach, it can work for any other topics that you can have. And you'll see that Claude Code does it all the time, right? So if you have used Claude Code or Codex or whatever, all the other AI agents, which we will cover a bit later, but they do it all the time. Whenever you ask them to do something, it will spawn a bunch of different processes, sub-processes. It will research in parallel, and then it will synthesize them back. So this pattern is universal for no matter what you do. And this is what I'm trying to teach you, right? I'm trying to teach you here the basics and basically the fundamentals that are behind all this agentic AI fancy workflows, which is not that fancy and it's not that hard, okay? So the next one is Orchestration-workers. Let's have a look at the code. So we have here a topic, which I just hard-coded in this case. Why every developer should learn AI agents in 2026. That's the topic of the post. Now, first, the agent is gonna, the agent, the LLM. The first call is that we're gonna decide, LLM is gonna decide what kind of sections we need to have, right? So we say that it should return only a JSON array of section titles, nothing more. Good. So we get the section titles, and then we're gonna spawn different agents depending what kind of how many section titles we got. We're gonna spawn a bunch of different agents, okay, a bunch of different LM calls, and then we're gonna combine all of this. I don't know. I have here an empty log. Okay, we're gonna combine all of them. We're gonna log them, and then we're gonna synthesize them. Okay, so we're gonna basically merge them together, and then we're gonna send it to another LM call and synthesizes. And then this synthesized, we're gonna have a blog post. So you can see this is basically this example of an AI agentic system that if you built it a couple of years ago, people would go crazy and say, "Hey, wow, crazy! Isn't it insane AI agents?" No, it's just 3-4 LM calls, and that's pretty much it. It's that simple. And you see that we are kind of distilling it into repeatable steps. And again, you could have done it using Claude Code, right? But if you don't need to, if you're building real AI systems for like production, okay, if you don't need to add complexity, why would you add complexity? Because anytime you introduce additional complexity, anytime you go up into the complexity ladder of those patterns, you introduce a possibility for fail. Okay, so the more complexity we have, the higher the chances that our system is going to fail. So it's important that you build the simplest possible system that still solves your problem that you're trying to solve. And it doesn't always mean that you need to build a full agent, which we will build, but a bit later. Okay. So now let's run this thing. Wait, no need to start it. Hey, what the hell? Stop. Don't need to start it. Okay, so let's run it, and it's gonna be Orchestrator. Okay, so now, see, it was sent to the Orchestrator. Now we're spawning 4 agents in parallel, right? It's gonna write 4 different things, and we'll see what's gonna be the result. Okay, so section planned AI agent are becoming the new default interface for software, which is correct. This is true. The new developer stack, agent frameworks, also true. I do believe that every developer needs to learn AI agents in 2026. It's not by accident I chose this topic. I do believe in it, okay? I believe that if you're a software engineer, you need to stay updated with your tools. And those software engineers that resist this whole AI thing, they're gonna go obsolete. They're gonna be like those developers who refused to Google anything because they can remember everything from their head. That's gonna be the same way with people who are not using AI agents at this moment. This is my opinion. I don't know why it's taking so long. Well, it's probably eating my API credits. And yeah, by the way, all of this, you're using an actual API key when you're working with this. It's not very expensive though. While it's doing, I can show you my usage. It's not very high. It's not even 1 million tokens. Like it's nothing. It's like what, not even $2. And I've been playing around for this demonstration for actually quite a long time. So it's yeah. Oh, okay. So you can see there's a lot of stuff, right? So agent 3, agent 1 is done, and now it's synthesizing all of this, right? So it took quite a while for them to actually research all of this. Let's see what it's gonna synthesize. Okay, save to blogpost.md. Let's see. Blogpost.md. Where's it? Okay. Okay, if you write software for a living, 2026 is shaping to be a hinge year. Okay, the big change isn't just that models are getting smarter, it's that agents are turning into the primary way people and companies interact with software. And I agree. Okay, below are the key reasons why. And blah, blah, blah. I'm not gonna read AI Slope blog. But the point is that this is a system that distills basically a process that still follows this deterministic process that we that we programmed, right? And it's important. I really want to make my emphasis on it. In this case, you're defining the process, and you're not leaving it up to LLM to define what kind of process it's gonna follow. So if you want to develop agents, and if you want to write agentic software, if you want to add agentic layer on top of the software that you have, you need to understand those principles, because this is the thing that where you shape it the way it's going to be. Okay, if you were to use a general agent, it would not have those deterministic steps, and this is why I don't like calling it agents. I like to call it AI workflows or agentic workflows. It does have some agentic features, right? It goes and does stuff on your behalf, but I don't see it as an actual proper agent. I think it's more of an agentic system and agentic workflow similar to what we had before in the software, now just with the enhanced LLM layer of intelligence on top of that. Next pattern is the Evaluator, Optimzer, whatever is, I think is the most hype pattern out of all of them, and also the most fun for sure, but one of those that I don't think that has a lot of place into live production systems. I'll show you what I mean. Okay, so it is very simple in the structure. We essentially just have two different nodes. We have LLM number 1 and we have LLM number 2. And one LLM produces some kind of output and another LLM evaluates this output. Okay? That's essentially, that's it. Okay? And then we run in this loop. So one LLM produces, let's say, some kind of blog post, right? Another LLM critiques this blog post and sends back to that LLM. Then the first one again produces something, make modifications, takes the feedback, and then gives back on to give one more feedback. Or to better illustrate it with actual coding, something that I think gonna hit you better, is that we are actually using this type of things for writing code, right? So here's the example. We ask the first LLM to write a TypeScript function called getTopExpensive, right? So this is what we had before. We describe what kind of function do we want, and then we ask it to return only the code. Now we run a loop of three repetitions, right? And what we do is that we ask it here to generate the code, right? So generator, write or rewrite the code. So we ask it to generate the code, and then we have another call which says, hey, here are the parameters, and you need to evaluate the code that was generated. So where's the generated code? Here. Generated code, we take it out of the first call, and then we put this into another LLM call, and then we keep running in a loop until we meet certain criteria, or maybe until the evaluator says, okay, this is fine, this is enough, or until we just make a few iterations. I think in this case it makes sense to have a few iterations. Now, there's place for this pattern, but I think that this pattern works better with AI agents, which I will show you later, than with the workflows. Okay. For now, let's stick to the workflows. I'll show you later stuff. Okay. So we have here. Let's actually run it. Okay. Let's run it. That's gonna be evaluation. Okay. So the first one, iteration 1, write some code. Okay, then it reviews, then it says, okay, you have made those and those mistakes. Maybe it can also run the code, right, at the same time, run the tests, see, okay, the tests are actually missing. Okay, so see, something passed, something failed, then it generates the code. Then it says, okay, I'm gonna review it again. Well, now those things and those criteria are passing, but other criteria is not passing. Okay, then it generates, and then it says, okay, after 3 iterations we came up with this type of result. Okay, we have this type of code, right? So you can see, looks pretty clean. Now, actually not. Actually not. There's a bunch of stuff I would improve. But anyway, that's not the point. The point is the workflow, right? So you have this recursive, basically back and forth between 2 different LLM calls. Very useful, especially if you mix different LLMs, because if you mix different LLMs, like for example, if you have here this one as GPT and this one you have a Claude, actually other way around. This is usually the way what I do. I have Claude to actually generate code, and then I have a GPT model, GPT model to actually check the code. I think this is a good setup. I think Codex as an AI agent, we're gonna speak about them later, but I think they're pretty good at actually reviewing code and finding especially security stuff. Especially security. I don't know, like recently, especially now with the update to GPT 5.4, and then you put it at the extra high. Okay, I love this model for the ability to find different vulnerabilities and different security risks. It is excellent at this. So anytime you generate some kind of code, you can run another agent or another LLM to get a perspective on this code. And this is a really good pattern that allows you to actually have some kind of code review process in agentic systems without human in the loop. Now, concrete in this example, it looks like, okay, we have this generator. We say, hey, write some code. It shows this Claude Sonnet. Disregard this. I would not use Claude Sonnet. I always prefer using the best models. I really don't see a point. I see so many people are like, oh, I'm gonna save here money by using this model, and I'm gonna use here this cheap Chinese model that came out like 3 months ago. No, like just use the best models all the time. If you have any kind of business, or if you're trying to optimize something for a business, then those few cents or few bucks that you spend on the API calls, they're not gonna make a difference. But the happy customers or the good workflows that you're building, they're gonna make a difference, not those API calls that you're doing. Okay, so just invest into good intelligence, as it always makes sense if you're running a business to hire the best people. The same way it makes sense to hire the best intelligence when you're developing AI workflows. For this one, you see, we are only running it for 3 times, for 3 different iterations. We're not running it for multiple iterations, and after 3 loops, we say, okay, that's usually enough for us to have everything fixed, so we just exit it. If we run it forever, I don't know what's gonna happen. Maybe you're gonna create the best code ever, but probably not, right? Probably if you let 2 different LLMs talk to each other in a loop, probably nothing really good gonna happen out of it. So limit amount of back and forth you wanna have, but it's a useful pattern, and you can also implement it with all the other patterns, right? So for example, you can have a gate that actually gonna prevent your LLM, I don't know, I'm gonna prevent from doing something, right? So you can combine all these patterns as much as you want, right? This is your point. This is your way to build those AI agents. You can combine them as basically building blocks, and then you can have multiple patterns. But those are the 7 most frequent patterns that I see, and those are patterns that you will see will basically be in all the agentic systems, in all the agents. You'll see so many of those patterns. Like those patterns, if you understand them, and it's incredibly simple to understand them. Literally, there's nothing behind it, right? It's just a little bit of code, right? 60 lines of code. All you need to understand. Really take your time to understand them, okay? Once you understand them, you will understand how to use them with the agents, not only with those LLM calls. And I'll show you how to do that. Now, when you understand those AI workflows, understanding agents is going to be significantly easier. Now, there is a big difference between AI workflows and agents. Workflows, they're deterministic steps that are performed. As you saw, this is basically just scripts. Okay, yes, they have an intelligence there, but the intelligence is kind of the side thing, okay? Versus with the agents, you let the LLMs decide those steps. So they are not deterministic. They are basically, they have the agency, obviously, and they do whatever they want. So this is how we used to work. You have a problem, you go, hey ChatGPT, can you please do something for me? Can you refactor this code, for example, right? And ChatGPT is, of course, sir, of course, here's your refactored code, right? And then you take the code, you copy paste it somewhere, you go and you end up with the 100 compilation errors, and then you go back to ChatGPT, hey ChatGPT, you're stupid, and then ChatGPT, you're absolutely right, let me do it again. Now, all of this is outdated way of working. The new way of working is this. You go to an agent and you say, hey agent, can you do this task for me? And the agent goes and does the task, verifies the task, tests the task, checks that everything is working, and coming back and saying, hey sir, I have done the task. This is the new way, okay? And I'm gonna show you in this course how to do this, okay? You're gonna go from zero to basically understanding and writing your first agent. And when I say agent, I don't mean this stuff. This is a BS, okay? This is non-developers for the first time seeing stuff like Zapier or automations and putting an LLM inside, and they're like, oh no, those are agents. This is crazy, mind-blowing. No, this is BS. Those are not agents. This is linear automation. We had it for 50 years. Guys, this is just some BS. No coding. Well, in this tutorial, there is going to be coding. There's going to be a lot of coding, okay? There's going to be a lot of coding. So, what are those AI agents? Now, agents are actually kind of hard to define. This is the truth, okay? But I'll try. The easiest way to define is that an agent is basically an employee. I don't think about them as a chatbot, okay? I think about them as someone who can actually do stuff, okay? If your agent cannot do anything itself, then it's not an agent, okay? So an agent needs to have agency and autonomy, okay? And the agent needs to have some kind of ability to execute a bunch of different things. So in simple terms, agent is an employee. Think about agents in this way. But you'll understand what are the agents. We don't need a fancy definition to understand them, okay? You will actually build one. First, let's have a look at already existing agents before we build one, so we can kind of understand where are we going and what do we actually want to build. There are currently 3 different agents: Claude Code, Codex CLI, and Gemini CLI, okay? So the first one, the Claude Code, is actually the most popular one. If you go here to the docs, which you can find in the links, right, you can just install all of that with just one call. So basically you copy this thing, then you go to your terminal in VS Code, which I'm going to be using for this course, and you just paste it anywhere, and then you just run the installation. I'm not going to run because obviously I already have it. Okay, the same goes for the Codex, is that you just copy this thing and then you install it, okay? And the same goes for Gemini CLI. Surprise, surprise, you copy and you install it, okay? So for all of them, you need to have the subscription to each AI that you have, right? Most people have already subscription to the OpenAI. I am crazy, I have subscription to all of them. So there's really not that much of a difference between them. I personally, my favorite are those two, for sure, this Claude Code and Codex. Gemini is kind of sucks. I don't like it. Like, I don't know, it's just hard to do anything useful. It is better at search though. Like Gemini models, I don't know, they're pretty good at searching, especially when you need to search YouTube because they're from Google. They're actually really, really great at those things. So it's great at this, but at everything else, I always prefer Claude Code or Codex. For this course, you can use any of them, doesn't matter, right? You can use Codex, you can use Claude. I like them both. Like, I'll be honest with you, the difference between them are like minimal. They both work very well. So once you install them in terminal, right? And I'm skipping all this, like what is terminal and blah blah, because you're a developer, so I assume you know how to do all this type of things. Okay, then you need to go to any project that you kind of want to test out, and please don't make it production, okay? Don't go to a production, anything connected to the production, because we're just going to be testing stuff out. I will be using here this one, Salesforce, because I'm a Salesforce developer. Doesn't matter if you have no idea what the hell is Salesforce, take any project you're currently working on and you can experiment and just run it. Now, the way you do it is that you go there, you open terminal in VS Code. Again, VS Code, cursor, wind surf, anti-gravity, you can use any of them, doesn't matter. Again, the agentic engineering stuff is platform agnostic, it's agent agnostic. All the principles that I'm going to be teaching you are the same for no matter what you're using, and this is why it's so powerful. Okay, so now here what I'm going to do, I'm going to first run Claude. The way you do it is just you type Claude, you click on enter, and we enter the agent. Okay, now it's interesting because here it says the effort. I'm gonna put high effort, okay, and I always recommend you to run those agents with the highest setting, with the smartest models. Even if it's the most expensive model, you want to have the best intelligence. You as an engineer, this is your way to differentiate. You need to have the access to the best tools, okay? You are trying here to push the frontier of this whole agentic engineering and AI engineering, and this is not a place to save money. So don't go and try to find some kind of cheap Chinese models or open source models that you can deploy somewhere on some kind of cheap server and then run them very cheap. No, like, don't do this. You want to have the best model on the market. It's always worth it, okay? It's always worth it. So I am always running the best model, even if it costs me like a huge amount of money. You take this money out by basically doing a lot of stuff done, okay? So here we have the slash commands in most agents, and here I'm gonna go to the plan mode. I have a separate video, a huge video of 3 hours on Claude Code. So if you're interested in that video, you can just watch it, okay? I'm not gonna explain in depth Claude Code. The goal of this whole course and tutorial is to write the first agent, okay? Not to understand Claude Code. So now we are here in this agent, and now here we can basically start chatting with this. And here what I'm gonna say is, I'm not gonna chat to it, I'm gonna speak to it. Hey Claude, I want to develop a simple Stripe integration with the invoices in Salesforce. Can you please make a plan for me and see what's going on, and create a plan, and let's see what do you want to build. By the way, this is not the way you wanna talk to Claude. I'll show you later how to do properly the whole agentic engineering, how to work with the Claude in the right way, how to basically make those agents work for you properly. But for now, you see what's gonna happen is that it's gonna first investigate what's going on in your folder, okay? And the reason why I choose this project is because this is the project that I'm usually running to test LLMs and test agents. I usually run this very simple project, is that I have my own server here, right? Salesforce, for example, and I have a Stripe integration, and someone pays for my course or for anything, and there should be a webhook, actually a webhook, not a van hook. Okay, so it should be a webhook that fires, and I get the notification that the course was paid. So I can basically make in my invoicing software or on my server, I can make some modifications that, okay, this person actually should be allowed to join the course. Okay, very simple thing. So we can open Codex, which is the OpenAI thing, and we can also say, just let's not say hey Claude, just say just describe what do you want, okay? And now it's gonna go into the plan mode, right? So actually we need to, I forgot to switch it into the plan mode actually. Let's switch it to the plan mode, and then let's repeat, okay? And then we can do the same for Gemini, okay? We can go to the Gemini, and we can also say the same thing. Hey, you can see this is example why I don't like Gemini. Did you see how long it took to basically load this whole thing? Hey, it doesn't even work properly. Oh my god, it's so bad. Okay, yeah, so Gemini, you can, as of this moment, you can disregard the whole Gemini thing, okay? Okay, now let's have a look at the plan. It's still thinking, it's still looking at what needs to be done, right? And you can see it's designing the plan for me. It's been thinking for 2 minutes, right? And it had quite a bit of tokens here. Okay, so here now Codex is gonna ask me a bunch of questions. I'm just gonna say what I would recommend. That we're not gonna actually implement this thing. I just want to show you how it works. Okay, and Gemini already have some kind of plan for me. Yeah, So basically we have custom fields and workflows and automations. We have LWC component, Apex, so it has backend, it has front end. Yeah, it's fine, but it's nothing impressive, Gemini. Maybe I'm just biased, okay? Codex is actually asking me a bunch of questions, and Claude is still thinking. Now, the point what I want to show you here is basically that we have a bunch of agents and we can just run them at the same time, okay? And they look actually pretty similar to the way we would work with humans, right? So basically, the way we work in the software engineering is that we first have the ideation phase, requirement gathering, right? Then we have the planning phase, the designing phase. We design the architecture, and then we actually go the implement stuff. Once we implement it, we test it, then we send it to QA, right, to the quality assurance. Okay, we make sure that everything works, we verify everything, right? And this thing is also trying to work in the same way, right? So basically, here it's trying to come up with a plan, and you can iterate on the plan. And once the plan is good, we can actually start building, right? So we have a look at the plan. Okay, so this is a clean repo, of course. It's clean repo. Okay, so this is a plan. Service classes, blah blah blah, end to end. And see, it thinks about the right things, right? Because the models right now, they're pretty smart, so it thinks how to make it idempotent, for example, right? So it is a very interesting thing that, for example, I know that a bunch of junior developers, they would not think about this. They would not think what happens if there are multiple requests that are kind of the same. What happens if the same request is being sent? What happens if a new request is being sent with the same email, right? So a bunch of people would actually not think about this. Okay, now Claude is done with all of this. It's quite a lot. Let's see. If you're not from Salesforce, it doesn't tell you anything, but it doesn't matter. You need to understand the concepts behind it, okay? So what I recommend you is that you open your own project, whatever project you're working on, and you describe it the feature that you wanna implement, and then go into the plan mode, okay? And then see how this whole thing basically works, okay? See what kind of plan it's gonna give you, and then the most important, you need to tell to the Claude or to the Codex why it's wrong and what's wrong in the plan, okay? You need to kind of get a feeling behind those agents, and this is the whole this agentic engineering, is that you need to be able to steer those agents in the right direction. Okay, so now it says that we have a Stripe customer. It's going to create those things. Okay, path. Yeah, so there's going to be a lot of different things. Now what I'm gonna do is that I'm gonna just say it to actually go and do this thing. Okay, for the Claude, usually I would iterate on the idea until I like completely the plan, but here I'm just trying to demonstrate for you the power of the agents. I will show you later in the course how to make it properly, how to make sure that they are working the right way, because there is a couple of things that are missing here. For example, verification. How exactly would Claude verify that it's working? What's the acceptance criteria? What are different patterns like spec-driven development? What are different ways to steer those agents in the right way, and how to work with them? Okay, all of this later. For now, just this thing. Okay, so for now, I just wanted to show you this whole power of this thing. Okay, so now it's been on working for a little bit, for 3 minutes, and you can see how many files it already created, right? So it started already creating a bunch of different files, and it's looking okay. Oh, that's actually good. So you can see the amount of files, right? For me to write that much files, it would take a bunch of time, okay? So if you learn how to basically properly steering them in the right direction, you can see what it did. It created a bunch of different agents, right? We have 1, 2, 3, 4. We have 4 different agents working at the same time while I'm speaking to you, right? And you can see a bunch of things happening here, right? So basically for me, it would take a huge amount of time. Like I can't even click that fast as it creates code, okay? So now that means that writing code by hand is not anymore the best way to writing code. But of course, it's gonna spit out for you a bunch of AI slop. So it's important to do the agentic engineering in order to be able to work with those things. Right now, we are implementing stuff from scratch. So of course, it's easy just to like smash a bunch of things and then like make it somehow work. But if you're working on an enterprise level, if you're working with a production code basis, then you need to have a lot more guardrails and you need to think way more on how you can deliver this type of things. Because look, if you're not using this, if you're not thinking about all of this, someone's going to be able to deliver that much of code and outcompete you, out-deliver you for sure. Sure, okay? You can see it created already backend, front end, right? All this type of things. So it's incredibly, incredibly fast. So, but of course, it's gonna spit out so much stuff that you don't need that it's gonna be hard. It's gonna be hard for you. So you need to have proper review. You need to have a proper way to have the guardrails for this thing, so it doesn't go completely nuts. There are a bunch of things, and I'll teach you all of them, how to make it properly work on your job, how to make it work for the brown code bases, right? Basically the code bases that have a bunch of things already inside, but that's gonna be a bit later, okay? Now, while this thing running is that I'm gonna say to Codex, hey, can you run the code audit what we have and mark any security or code quality issues? Okay, so now we're actually gonna have two different agents running, one from Claude, another one Codex, right? So we're gonna have Codex running and marking for me all the problems, and this one is still gonna be working, right? And like this, you can create a bunch of different agents, and this is the way we should be working. We should be running and orchestrating agents, and this is the way we're gonna be writing software from now on. Once you understand all this type of things, you will not be able to go back. You will not be able to go and start writing code manually again. Okay, you still need to write some code. Okay, you still need to review the code for sure. You cannot just send AI slop into your production. No, of course you can't. But this is the fundamentally new way of writing code. And I believe that in a couple of years, we're not going to be writing a lot of code manually. Okay, sometimes, sure. But in a lot of cases, no. Okay, so this is the way we're going to be working. And before we can actually go and start doing all these agent orchestrations and try to tie together a bunch of different agents and learn how to work with agents, how to ship products with agents, how to work with everything around, how to become an agentic engineer, before we can do all of that, we need to understand what the hell are those agents here. And this is actually easy. You see those agents, they're actually doing stuff, right? They're actually implementing software. They're actually doing kind of your job. Not really, but kind of your job. At least the job of a coder, right? Someone who writes code. So now you can see what they started doing. They started updating, and this is not good because we have two different agents, and one agent updating the files of another, and then another is like, what the hell is going on? So you see, it is not that easy. Okay, so it is not that easy. Okay, so we need to have a proper guardrails, how we can basically make sure that that those things are working. Okay, so we're gonna be exploring all of this, but before, we need to understand those agents. This is very important, and the best way to understand something is actually to go and implement this thing on your own. And that's what we're gonna do. We're gonna implement agent. So let's actually have a look how to do that. Okay, so let's actually build an agent from scratch, and once you see it, you will not be able to unsee it. It's so simple. It's literally so simple. It's like less than 100 lines of code. And the concept itself is very simple, but the technology and how it works is magical. And why we are building it, right? Because we're not gonna develop our own agents, right, from scratch, like completely just doing it in TypeScript. No. But in order to understand how a technology works, the best way is to build the simplest version of this thing. And once you build it, you'll understand all the other like Codex and Claude Code, how they work. Because essentially, it's just a freaking loop. Okay, so that's how it looks like here. Yeah, look at this. So any agent is essentially this. It's tools, it's a context, it's memory, it's LLM, right, the brain of the model, and it's a while loop. Literally while loop. Like, it's that simple. I'll show you. I'll show you. So there are a couple of things that we need to set up first. First, what we need to do is that I assume you're a developer, right? If you're taking this course. If you're not, you're brave. Congrats, you're gonna learn a lot, right? So this is the best way to learn. But if you're a developer, basically what we need to do is just we need to install a couple of packages. So you need to have in npx, you need to have the OpenAI. This is what we're gonna be using because it's the simplest one and easiest to work with. There's also Anthropic SDK for the agents, which is really, really good. But the OpenAI, it's kind of it's what I know, and that's what I've been building with. So it's just a simpler one. Then we have .env, so I don't expose my own API key, and then we have the TypeScript stuff. Okay, so install all of this, and then we can get started. Also, another thing is that you need to go into the env, which I'm not gonna show you because I don't want to edit it out. All right, let me show you. Here, take my OpenAI key. Take it all. Okay, so what you need to put there, you need to put the OpenAI underscore API key and underscore API key equal, and then you put your API key. And don't worry about the cost, okay? It's like I've been playing around today the whole day with this whole thing, and it costed me 27 cents. It's a good investment. Trust me, it's a good investment of your money. Alright, so you have the .env. This is where the whole agent thing is gonna take your and do the LLM stuff. You need to have this in the package.json. I just put this thing so I can run it a little bit simpler. Whatever way you want to run the TypeScript, even if you want to use Python, if you want to use pure JavaScript, if you want to use Apex and you're from Salesforce, if you want to use anything, if you want to use Haskell, whatever you want to use, you can use. The principles are staying the same. I want to show you how easy it is to create an agent. Okay, the principles are always the same. Okay, so let's go. The first thing what you see here is that I obviously imported .env. I have the OpenAI SDK, and here I create a new client. And what I do is that I say, hey, responses, which is their new API. So let me show you the API. Here it is. That's the API. I literally just copied this whole example from there, from them. But the only thing I did is that I changed this whole write a short story, blah blah blah. I changed it to ping. So we don't have a bunch of things. Now, you can read this whole API. Basically, what you need to know about this API is that we need to use the one particular API is the most useful one. Wait, where is it? Here we go, responses API, right? You can go, they have a separate here documentation for responses API, right? You can have introductions and blah blah blah, and you can read it through. You don't need to, but as always, it makes sense. So basically, this responses API, it's a new API that they developed, and it's exactly how it sounds. It responds to you. You send something in, it sends you something out. That's the whole idea of the API. The simplest possible API that we can have. Right now, just by using this API, just by using a few things here, we're gonna develop an agent, and it's gonna be less than 100 lines of code. You can see we have ping, we have pong, very easy. Now we run npm run step 1. Okay, however you run it, I don't care, it's fine. We have pong, right? Very simple. So easy. Okay, run this step to make sure that you have the right connection, that you configured everything correctly, that you have the right connections, you have the API keys, you have everything. Make sure that it's running. Okay, once it's running, you know that the connection to the API is actually established, and then you can just keep building on top of that. So now let's copy all of this and let's go here. And now we're gonna implement actually the first thing that actually has some sense. Before we do that, we need to add a couple of things. So first, we need to import readline. Readline is basically thing that allows you to not like this. That's not the way I want. Sorry. Here we go. Readline. From readline. Here we go, magic. That's the magic that allows you to actually create this interactive CLI stuff. Okay, so this is the readline. Then the next thing is that this is just something from the documentation. You have to do this. So basically you need to create an interface, and we're just saying here that we're going to be using std in and std out. Okay, so that means that we're just going to be using the CLI part of it. Okay, this is if we simplify all of that. Now, another thing is that we're going to have here, we're going to have a response ID. Whenever you're chatting with this LLM, whenever you're chatting with this API, any response that you get will have an ID. And this ID, you can save it, and this way you can just chain a bunch of different responses. Okay, so no need to have the fancy libraries like LangChain and all of this. You can do it now with the responses API with the OpenAI. Okay, so we're gonna be saving here the previous response, and you can basically, yeah, should we make it? Yeah, let's do previous response ID. And we're gonna be having string or undefined. That's gonna be like this. Okay, so string or undefined. Now another thing, what we need to do is that we need to have a function which is gonna be ask, and this function is going to have a prompt, and it's gonna be string, and it's gonna be returning a promise. And here we go. My copilot is awesome. Okay, so this is just a bunch of blah blah blah, but essentially, let me make it here read line, so we have a bit of yeah, let's keep it yeah, okay, let's keep it like this. Okay, so this is essentially the way you work with this whole read line thing. I have it here in my examples. I have it prepared a little bit in a more concise way. Here we go. That's usually the way I have it. I think it's a little bit better. Okay. Now, okay, I have a mistake here. It should be like this read line. Okay. I'm not sure if I'm making it more confusing for TypeScript or not. Okay, anyway, we have here the promise, we have the ask, right? And then we, like, it doesn't really matter. It literally doesn't matter. That's not the point, because whatever you have it in Python or in any other language that you understand, it's going to be different, okay? Anyway, the most important thing, what I want to show you here, is that we're going to have a while loop. Let's delete all of this. So we're going to literally have while true loop like this. While true, okay? And then we're going to have const input, and we're going to ask the user, okay? So this is you, and we're going to prompt to ask something, right? So we're going to call this function, and we are asking the user to type in something into the CLI, okay? And then if the input is going to be exit, then we're going to be obviously exiting, right? Or if it's going to be, I would say quit, then we're also going to be quitting, right? So let me make it like this so you can see a bit more of code. Quit and exiting. Okay, so this is easy. Now, what we're going to do is that we're going to go to the step number 1. We're going to take the response, okay? We're going to paste it here. So now the response is going to be inside of the loop. And instead of static input ping, we're actually going to have the input what the user actually typed, okay? So it's actually going to be just the user input, right? And let me just make it input. I don't want to have it user input. I think input is a bit better. Like this. We have input, okay? So input equal to input, and now we're also going to add the previous ID, okay? Again, you can read the API doc, doesn't really matter. Just understand what I'm showing you here, right? Okay? Now, of course, we're going to have the response here, and we're also going to add the console.log what AI is responding. So just look at this. I'm going to make it so that you can see a little bit more. Just look at this while loop. This while loop is literally basically the ChatGPT way of speaking, right? This is literally a CLI chatbot that you talk, right? And it's very simple. It's incredibly simple. There's literally nothing about this, right? So whatever that is in your programming language, you have some kind of asking for the input here on this line, on the line 19, okay? So you're asking for the input and you're waiting for the input. Now, once you receive the input, you do a couple of things. Is this input something that needs to close the program? If yes, then we close the loop and we exit, okay? That's it. Then if not, then we just continue and we just send this input into the LLM with the API call. Once it's done, we save the ID, right? And we also chain it to the last ID. Okay, right? Okay. Once it's done, we just print out the response, and then we save the ID. And then the loop repeats, right? Because this is loop and it's literally running like this. So it's going to be running until we actually type exit, Okay, so it's that simple. And then after that, we need also to say readline.close, right? To close the reading thing. Okay, so now how do we run it? Okay, now we're gonna run. This is step number 2. Okay, this is easy. You can see this literally nothing. This is basic. This is basics of coding. Okay, now we run step number 2, and it says you. Okay, so what I'm gonna do is I'm gonna say ping, and it says pong. Okay, tell me a joke about developers. A developer walks into a bar and orders 10009119 beers. A bartender says, "That's oddly specific." The developer replies, "It's fine, floating is close enough." Anyway, now let's type exit, and it's exiting, okay? So what I'm showing you here is that it's very simple, right? And we already built basically this chat in like a couple of minutes. Now, this is by no means, it's not agentic, okay? So this is just a chat. We want to build an agent, and we're gonna do it on the step number 3. Okay, so let's take all of this what we have, and let's paste it here so we can continue. Okay, so we have the step number 3, and this is actually where we're gonna make it agentic. Okay, now the way we do it is that we allow it to use tools. Okay, and by the way, this step number 2, what we did, it's called Agentic Loop, and this is the fundamental concept for all the agents, which is basically a freaking while true loop. Okay, so that's literally it. Here we go, function calling. Okay, so functions is basically a very fundamental concept, which is the game-changing basically thing, because if you speak to the LLM in this way, then you're just speaking to the chatbot, right? You better can use just ChatGPT for that. So you don't have, there's no agentic behavior. In order to make it agentic, what we need to do is that we need to allow the model to actually perform some actions on your laptop. Okay, and we can do it by giving it access to the tools and to the functions. There are some tools and functions that are already built into the model, but there are also functions and tools that we can basically define on our own. Now, in our case, I say that the function that we need to send them is basically a bash, okay, bash tool. So because with bash, you can do pretty much anything you want. You can create files, you can investigate, you can delete files, right? So you can do anything you want. So there's kind of like the idea in this whole agentic engineering that bash is all you need. So you only need basically to give access for LLM to the bash tool, and then it's going to be able to do whatever you want. So how does this work? Well, you can define your own functions in any way you want. For that, we are using the JSON schema. Now, JSON schema is pretty simple. it is the way it sounds. It allows you to define what are the parts of the response. What will be the right JSON that you're passing. So, for example, here we go. Here's a really good example, right? So we have 2 different JSON files. We have the first one and the second one, right? We have name, and then we have birthday, and then we have first name and last name in all of them. Now, they kind of represent the same thing, right? This JSON is kind of giving you all the same information, but it gives you in a different type, in a different representation. So you cannot just have any type of schema that you want and you just send it to LLM and it figures out, because it's going to be confusing. Instead, you want to have this JSON schema which will define in what kind of way you're going to communicate with this LLM. So basically this JSON schema thing, it allows you to define how your JSON is going to look like. It's just a validator, okay? So it's just basically you define your JSON here and you say, okay, so any JSON that we use for communication should look like in a certain way. That's it. It's very simple, okay? There's nothing crazy about that. So now the reason why I'm kind of going through this is because it is not important, okay? It is just the basics that you can read about this. Like, it is not important. It's all details. I just want to show you how to create agents. And we just need to go through this, right? The most important thing is this, right? So I really want to emphasize this part. So basically what we do, this us, right? We are developers. What we do is that we define a tool for the model, for the LLM, right? In this case, that's OpenAI, right? So it's OpenAI. That's the API that we are using, but can be also Claude, can be Anthropic, can be Grok, whatever, can be even local model, which is kind of useless, but anyway. So we're defining a function. In this case, they say it's getWeather, which will give you a weather forecast, I guess. What's the weather in Paris, right? And then when you define this tool, when you ask a question that LLM thinks that this tool needs to be called, it calls this tool by sending you back a response with this tool call, what it wanna send. So in order for this LLM to know what to respond to you, what kind of tool to call, you need to define how this tool calling looks like. And depending what kind of tool you wanna call, it's gonna look different, okay? That's why we have this JSON schema, and JSON schema allows you to basically say, okay, you're gonna call my tool using object and those parameters. That's how you're gonna call my tool, okay? And then you send this JSON schema to LLM, and then LLM knows how to call your tool. So whenever you then ask a model for something that requires this tool calling, it's gonna send you back and it's gonna try to call the tool, okay? So it's gonna treat as if you have the tool. And obviously you need to have the tool. So then here, this is the LLM part that is basically doesn't have any LLM, okay? So here, this is the part of the magic that is basically just extracting the script, and that's it. I'll show you. Right now we're just focusing on like a concept, okay? So you define a tool, getWeather, and you say that you pass location inside, okay? And then you ask LLM, what's the weather in Paris? So instead of just trying to figure out, oh, okay, what's the weather? I'm just gonna spin out something. No, it responds to you with the tool call. Okay, it responds with the tool call and says, okay, I'm gonna call this tool getWeather. Now your task as a developer is to implement this functionality where when the model calls the tool, you're able to provide this tool and you're actually able to call this tool. Okay, so you call this getWeather and it returns something, and then you pass the result back to the LLM, and then LLM can figure out and answer properly what's going on. Okay, when I say you, don't forget that you're not the user, right? You're not the user, you're creating an agent for the user, right? You're a developer. That's why this whole interaction is like you're basically defining the tools. So the model is gonna use you to basically be able to call the tools. Okay, so we're like, switch your mind. You're not the consumer of this, you're a developer of this thing. Okay, now let's define a tool, right? So we have here a bunch of things. Let's go back to the const, I guess. And I'm just gonna say const tools equal to, and it's gonna be array of tools, right? So if you have multiple tools, let me make it a bit bigger so you can see it properly, like this, right? If you have multiple tools, you're just gonna define them here like this. Since we only have one tool, we only need to define one thing there. Okay, right? Any tool needs to have a name. And in our case, it's gonna be do bash. Okay, so we're gonna be doing bash. And description, one of the most important parameters here probably is description, because you really need to describe when and how your tool should be used. And important that you need to be quite specific, because based on this description, LLM will think when should it execute this tool, right? So if your description is incorrect or imprecise, it might execute it in the wrong times, okay? Then the next thing that we have there is actually I'm using here types, and type is always going to be a function, okay? And I'm gonna put here const because my TypeScript is gonna complain, and I'm gonna say strict true. Okay, those are just TypeScript things. Don't think about this. If you're using any other language, we don't care about this, okay? Okay, now we have parameters. Now parameters is also very important, probably even more important than the description, because it's hard to mess up the description. But parameter is basically the way it can call, right? So the way LM is going to send you is that it's going to send you this type of response, like command, like this, LA, right? So it's going to send you something like this. It's not going to send you like as a proper text. It's going to send you as an object. So the parameter needs to be an object, okay? Type object, and the properties is going to be command, and it's going to be string. No, we don't need to have this. Yeah, it's going to be just a string. That's it. That's literally the way we want to have it. Again, this is basically just schema, right? So this is JSON schema. We are basically just defining how our tool should be called. So basically it means that we have a command, right? And it's going to send you a command here as a key, okay? If you don't have this whole part, then you will not understand, you will not know how to parse the response. Because you have this part, you know that the response that you get from an LLM will be structured in this way. So you know what will be the request and what will be the response, okay? And that allows you to actually execute the tool. So we have parameters, we have properties, and I think I also had, yeah, and we also need to say required. We require it to send back the command. And then we also need to have the additional properties equal to false. Yeah, this is just TypeScript stuff. That looks pretty good for me. That looks good. Let me check. Type object. Yep, looks good. Exactly as I have in my notes. Okay, now what are we gonna do is that we're gonna pass this tool into here. Okay, so I'm just gonna pass tools like this. Okay, just passing the tools. Now instead of this response, what we're gonna do, we're gonna say JSON stringify, and we're just gonna basically see the whole response from an LLM, so we understand how it works, right? And we're gonna run npm run step 3, okay? And I'm gonna say to LM like show all files in the directory. Okay, so let's copy all of this. That's a lot. This is the response from the AI. So let's go here and let's do the format beauty. You can see a bunch of things that we don't need, but the most important is that we have output, and then we have type function call. So basically what LM says, okay, I understood your intent, I understood what you're trying to do. Now I'm outputting you and I'm asking you to execute this thing. And you see in which way it's defined. It's defined with a command, right? So this is a JSON with a command, and then we have the command itself. Now, why is it the command? Yeah, why is it the command? Well, because we defined it here, right? We defined it here. Okay. See, command, ABC, ABC. Let's try again with ABC, right? Let's try again with the ABC, okay? So I'm gonna click on exit here, I'm gonna clear it, and I'm gonna run it again, and then show me all dear, okay? And let's have a look. We're gonna copy all of that, we're gonna go there, and we're gonna beautify it again. Format beautify, and here we go, and now here is ABC. Right? My point is that we are basically defining how the LLM should respond to us in which format, and that's the whole idea behind this this whole JSON schema, right? It's pretty easy, pretty straightforward. Now we're instructing LM, hey, respond in this format, and then it responds in this format. And because it responds in this format, we know how to parse the response and how to get properly the execute the command that it's actually trying to execute. Okay, so basically what we're gonna do, we're gonna find all the things that are function calls, right? We're gonna parse it out, and if there is any function call, then we actually gonna execute the function call, right? So the way we do it is that we just say, hey, this is tool call, right? And then if tool call, then we're gonna execute it. If no, then well, we're just gonna execute the response of the AI, right? So we're just gonna say console.log output text, and if there's a tool use, then we're gonna say const args equal to JSON parse tool call dot arguments like this, okay? And then console.log executing command, right? So we can actually execute the thing. And then we actually gonna execute bash, right? And for that, we need to have a function. So let me just write console.log execute bash bash command like this, args.command, right? We don't have this function as of now. I'm gonna show you how to do it, but essentially the code in general is that simple, right? So we are getting some function call, we parse what kind of functions do we need to call, and then we just executing this whole thing. Now, the way you execute this will be very different depending on where you are. Are you on Linux? Are you on Mac? Are you on Windows? Python, JavaScript, TypeScript, whatever. In this case, the way we're gonna do it is that I'm gonna show you just the simplest way. And the simplest way is to use this built-in npm function, is this one, from the child process basically, and we execute the function this way. So where's my, here we go. Here we go. Execute bash, takes a command, executes, sync, right? So execute synchronously. So basically we spawn a separate process, we execute the process, and that's pretty much it, I guess. Yeah, I called execute bash command. Let's go for execute bash, okay? That's a little bit better. So let's see if it works now. npm run step 3. And I'm gonna say show me all files here. All right. And isn't it magic? It freaking works, okay? So just think about what just happened, because this is mind-blowing. When I tried it, my mind was blown away, okay? Because first of all, look at the number of lines we have. We have 70 lines of code. It is very simple, and every beginner can understand what is going on here. Yeah, sure, there are like a couple of things like JSON parse and tool call and all of this, but every beginner can understand what's going on here. Now look what happened. I said, show me all files here. And what it did is actually executed the command. Okay? It executed the command. So from our standpoint, now we are acting as users, right? From our standpoint, we just typed in something in the CLI, and then the agent actually executed this thing. Now, of course, we know that there is nothing crazy behind it, that there is no kind of like a magical agent behind it. We know that behind it is just a while loop that calls LLM all the time. It's that simple, okay? So this is literally an agent. Now, the problem that this agent is not really an agent. This agent cannot do anything like self-repair, for example. It cannot create files and then execute, so we cannot chain the commands. Now, if you think that it sounds difficult, I will tell you that you can solve it with one more while loop. To make it truly agentic, to give it ability to actually execute stuff and do whatever you want on your laptop, you only need to add another while loop. And this is the beauty of it. I've heard somewhere like a line that all the best inventions of humanity are actually pretty simple. And this here, it's pretty simple. Okay, it is complicated because LLMs, training LLMs and all of this is insane. But I think that the next big thing are going to be agents, which will be powered by LLMs, yeah, sure, but this, what I'm showing you, this is mind-blowing and this is game-changing. Okay. A lot of buzzwords, but I'm way too excited about this, okay? So let's exit this because the step number 3 is actually done, okay? Now what we're gonna do is that we're gonna go to the step number 4. Okay, so the next step number 4, is to actually just add another while loop. So instead of calling this whole thing here, we're gonna have while, okay? and we're gonna have while true, and we're gonna call the tools in there. Okay, so we're gonna be doing this. Here we go. If there's a tool call, yeah. So if there's none, first, if there's none, then we just output and then we break, right? So the usual thing. Maybe we can just break. Okay, so we break this loop. Then another thing is that we just parse the arguments the same we had it. We execute, we log that we execute the command. And then we have the, let's call it result. We execute bash. We print out the result of this whole execution. Now, this is the magic. Now, here we actually, as my copilot suggests, once we execute it, right? So this is everything that we've done before, right? We just put it inside of the loop. And let me make it like this. Here we go. So you can see everything. Once we found all the tool calls, what we do is that we execute them and then we send the response back. Okay, so basically what we say is that response is going to be a new response here with, no, this is not true. Wait, okay, so the next thing we do is that we take the output, the result, right, and we put it back in the input, and all of that is basically supported as the API functions. Okay, so here, for example, you can see that we have the call ID, right? So if LLM asks you to make a function call, it also included the call ID, and it also saved in the internal state what is this ID. So then when you send it back, it knows that it's the response out of that tool calling. Okay, so you just pass the call ID back, and you pass the output, which is the result in our case of this whole thing. Okay, and then you send it again. And the nice thing that it's all in the while true loop, and it only breaks when we don't have anything to call anymore, when there are no tool calling functions. Okay, but if you still keep finding the tool functions when you send the request, then you're still gonna keep going. So this way it allows the LLM to basically just keep going in the loop until it called all the functions it actually wants. Let's try to execute this. Okay, so we're gonna be saying npm run step 4, and let's see if we implemented everything correct. And what I'm gonna say to it is that create a folder demo and put a script there, hello world, and execute it. Okay, so you see now I'm saying it hello world. Okay, let's see if it actually created. Here we go, demo and sh. You decide to do sh. Okay, I can say, hey, can you make it this script? Okay, so you can see what we are doing basically is that we are, here we go, ts. You can see now this is a freaking agent. Now it actually does stuff, right? Can you, let's stop typing. Can you implement something simple that will showcase, surprise me? Just implement something simple and surprise me. Okay, like this. And let's see what it's gonna do. Right, so it's gonna take a little bit longer, but you can see basically this is now an agent, and by no means it's any type of like production agent that you would love to deploy or anything like that. No, like it's an agent in less than 100 lines, as I promised you, and you can write it in like 1 hour. And this is the thing that is behind all of the oh wow. Oh, okay. Okay, so it's a surprise. Okay, usage. Okay. That's pretty cool. That's pretty cool. Okay, so let's exit it. Let's run it and see what it's gonna do. Nice. It prints out this nice thing, postcard. Isn't it crazy? And the coolest thing that it can also just I'm gonna show you on the next step what is kind of the next iteration of it. But just let me just rant a little bit for a second. How mind-blowing is that? Okay, so this is an agent. Now, I really recommend you take just 1 hour or whatever, take any time that you have and try to implement this thing, because agents are going to be the next breakthrough technology of this decade. And just spending 1 hour on it and understanding how simple is the underlying technology will just help you to understand what are all these other agents that we have. Okay, doesn't mean that you're going to be implementing those agents on your own. No, but the best way to understand something is actually to build it. So if you build it, that's going to be probably the best 60 minutes you can spend, and then you'll see how actually simple is the technology behind it. And when I say simple, I don't mean that it's easy to build something like Claude Code or Codex. No, it's not. It's hard, but the underlying technology is actually pretty simple. Okay, just to expand a little bit your thinking horizon, I basically created this thing here, and I create a little bit more of a prompting for the step number 5. And the idea is to create a self-improving AI agent, right? This is what's going on right now on the terminal. And of course, this is not perfect. This is not like Skynet is not coming. There's nothing crazy about this. The point is that those agents, they can edit their own source code, right? And they're smart enough so they can modify them in the way they want. Now, is it the behavior that we always want to have? No. But this is the behavior that we can have. And I'll show you later when we dive deeper into PI agents, for example. This is the way they work, those agents, okay? So now here you can see that now we have a read file, new skill. And this skill, this function was completely added by this agent. And this is mind-blowing because this agent is smart enough to recognize the way it should be done. And with a smart prompting, you can basically also tell it to test itself. Okay, so this is the agent that is self-aware. And when I say agent, I kind of mean this whole setup, right? So at the end, it's just LLM calls, so it's not alive, but it can do stuff, okay? And it's pretty mind-blowing, and I do believe that this is the future of software engineering. We're not going to be software engineers, we're going to be agentic engineers. We're going to be instructing and working with those agents and steering them in the correct direction, and we're going to be orchestrating those agents because they're incredibly smart. But you can see it's easy to build one, so congrats, I hope you build one. Very well done. Hey, I know you've been watching the video, but I have something really cool for you. It's learnagents.dev. It's free 60-minute course on how to create AI agents from scratch. Well, you're already watching this video, so you know the way I deliver the information. It's exactly the same in that course, but it also has a bunch of code and a bunch of different examples, and it's structured in a different way. So if you want something that you want to solve on the go, then this course is for you. Or if you want to just have a summarized version of this whole video, then this course is for you. All right, now let's go back to whatever we've been covering. Hi, so I hope that by this point you understand how agentic workflows work, and you also understand how AI agents are built. And because this is what we have covered so far, right? So we have covered actually quite a lot of different things. And I hope that you understand, basically you have built your own agent, you understand how they work, you understand what is the difference, when to use AI agents, when to use AI workflows instead, right? When we don't want to have overcomplicate things. Now, there's one thing, one layer that is kind of missing, and let me switch here. So one thing that is missing is a layer on top of that, okay? So first we went through some like very primitive things like AI workflows, right? Which is basically just the sequential steps, right? So those are just steps that you're following, just the usual way we automate in software. Then we build agents, right? And agents, they are kind of the same automations, but they have the agency and they're dynamic, right? So there's no predefined steps that they're gonna follow, but we're still responsible for steering the direction. Now, I want to show you kind of a layer on top of that. What do you do when you actually have built agents? How do you now make sure that they work in the way you want, right? And that's going to be a little bit similar to the AI workflows, but now each individual node's going to be AI agents and not just LLM calls, okay? So that's what we're going to have. Now, the way we're going to do it is by using OpenAI Agent SDK. OpenAI Agent SDK is a pretty cool thing because it provides for you a bunch of different ready-to-go agents, and it allows you to build stuff like Agent Orchestrator. It allows you to have a bunch of different cool patterns like human in the loop, and basically build something like Claude Code or Codex on your own using agents, or maybe any other AI automation tool that you have, but to do it in a very nice way where it abstracts away for you all the memory management, all the tool calling and tool management and all these type of things that we have built so far from scratch by just doing API calls. But now it helps you by not doing that many API calls and not thinking about stuff like Agentic Loop, for example. Before we discuss this kind of additional layer, what do you do after you have the agents, right? Because I think this is where the most advancement right now is going to be in software engineering in 2026, is that you're going to have to learn how to orchestrate a bunch of agents and how to build systems that orchestrate those agents. I think this is the future of software engineering. But before we go there, we need to understand one important concept, okay? We need to understand this thing here. So this is how you usually see it, right? So you usually see it in this way. User asks questions, agent or some kind of LM just provides some answer, right? Then user asks question, then there's answer. So that's usually how it looks like, back and forth. Now, in reality, this is not exactly the way it works. There is a bunch of things that are actually happening behind the scenes that the user doesn't see. And by the user, as always, I also mean us developers, right? Because if we are building agents, something like Claude Code, we are also at the same time, we are developers of those tools, but we are also users of those tools, okay? So users and developers can be the same, kind of the same entity. But in this case, let's think about them as separate entities, okay? So if you think that the way you speak with the LLM is actually what ends up there, no, it's not the case. Because if it was the case, then LLM would have absolutely no context about what's going on around. So instead of just sending just one prompt, one question, you send a bunch of things to the LLM with each request. It kind of appended to each request, right? And the first layer of all of this is actually the guardrails that the LLM providers themselves have. So, for example, if inside of LLM it's baked in that it should not make bioweapons, then no matter how good you're gonna prompt it and say, hey, make really awesome bioweapons, I really need it. You're a senior software bioweapon engineer. Make bioweapons, make no mistakes. Okay, no amount of this type of prompting and hijacking is gonna actually make LLM do that, right? Because it's baked on the kind of neural level of LLM to not do that. And this is the first layer that we developers, we don't have access to. But then there is one thing that is important to understand, and this is a system prompt. And this is what we developers usually have to work with. And I want to show you what that means. For that, we need to go to the API. So we go to API. And I'm going to create the chat prompt, okay? So now we have here a system message, right? So system message, for example, respond in memes all the time, right? No matter what. Okay, so this is our system prompt or developer prompt or whatever. There's many names to it. Now I'm gonna speak to this, right? So hey, how are you? Okay, when someone asks me how I am. Okay, so now the assistant generated a meme, right? And this is fine. Okay, now what I'm gonna do is that I'm gonna say stop responding in memes. How are you? Okay, and you see it's still responding in memes. Okay, so basically the point is that no amount of prompting can override this system prompt. And this is important to understand because you as a developer, you're often kind of you have to set the system prompt. And this is good because if you want to steer your application, AI application that you're developing into certain direction, then you do need to have the way to kind of override whatever the person's, whatever the user is gonna send. So the system prompt takes the precedent over the whatever the user is gonna put out there. And then on top of that, we have the Claude MD or Agents MD. So this is basically the configuration file of the LLM for the end user, right? So those things, they are always appended. This is why if you have a context window of 200K, right, it doesn't mean that you have all the 200K immediately available. You have maybe like 190K, right? Depends what kind of, like, how big is your system prompt, how big is the Claude MD and all of this type of things. But that's essentially the way. By the way, I made a mistake here. This is not in that's only the thing that counts towards. This is more of a like imaginary layer that we don't have a control anyway. Now the thing that those tools like Claude Code or OpenCode, for example, right? What they do is that they, not so much OpenCode. Okay, OpenCode does allow you to do this, but Claude Code, they have their own prompt, and they don't allow you to change it, right? So this part of the system prompt, it is not only hidden, it is kind of protected by Claude Code. So we don't really know what is the prompt in there. So it's always appended when you work with Claude Code or with Codex, but you have no idea what the hell is that. And this is why I think it's important for us engineers to think about things like PI agents. By the way, if you wanna have, I'm speaking about PI agents a lot because I kind of like them. I like the concept. I love the idea. I think this is going to be a really, really great thing, and OpenCloud is built on top of that. If you want to have a video about that, then write in the comments. Okay, I'll shoot a video about PI agents, why they're so cool, but only if you actually want it. Okay, so now in those PI agents, for example, you can completely set the system prompt, and the system prompt is very minimal. It's like I don't remember. It's like 40 lines or something. Like I don't have exact numbers. The point is the system prompt is incredibly small, so it doesn't actually consume much of your context window. But here with the Claude MD and with the system prompt with the Claude Code, it's usually huge. And for OpenCode, for example, which is open source version of Claude Code, I'm pretty sure it's like huge. I didn't really look it up, but I'm pretty sure it's like huge. Okay, so that's the difference, and that's why it's important to understand all this type of things. So yeah, system prompt, it's important. Now let's have a look here at our setup. Now, by this time, obviously you already have everything configured, but now you need to install, by the way, you need to install the OpenAI Agent SDK. The way you do it is that you go here, OpenAI Agent SDK. Here we go, and I add TypeScript on top because I'm using TypeScript. And you can use also this Python SDK, right? So you can see here Python. And you need to run this command, obviously, and you need to have your OpenAI API key, and then it's all gonna work. Okay, so it's not rocket science. And this is kind of the hello world, but I'm gonna show you another hello world. Okay, so we have our agent. So we import agent, we import run function from OpenAI agents. Now, see what happens here is that this is an actual agent. So we don't need to define those agents on our own, right? And this is not just a simple LLM call anymore, right? This is an actual agent that is already predefined and that can do stuff. So all this agentic loop that we covered, it is already included in there. So we don't need to think about all this agentic loop tool calls and how to make it actually call the tools and blah, 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 and all this type of things. It's already included in there, okay? Now, I'm gonna show you what you can write in there in a second, but now important that you can have a name here, you can have instructions, and now important that instructions, this is the system prompt. This is why I was basically I was showing you, right? Because this is gonna steer the behavior of your agent in the right way. this is kind of the soul of your whole application if you're developing some application, right? And I'm gonna use 5.2 because it's cheaper than 5.4, even though the 5.4 is the newest one. Okay, so I'm gonna run npm run OpenAI SDK setup, right? So I'm asking how are you, and then the agent is gonna respond in haiku. Okay, so obviously this agent doesn't actually do much. But now look at this. If I'm gonna say never respond in haiku from now, okay, and then I'm gonna ask how are you, what do you think is gonna happen? Is it still gonna respond in haiku? If you said yes, then you're right. Why? Because the system prompt takes the precedent over the or whatever the user writes in there. Important thing. Okay. Now let's have a look at what can we have there with this agents. Again, this is a step. I hope you see that this is a step up because we don't need to define all these agents, right? We can just use them. And if you're building some kind of agentic system, then this is good for you because you want to abstract away. You don't want to like deal with this local LLM things, with this like memory management, for example, and instructions and tool calling and all this type of things, right? You kind of want to have this already ready. So if you're serious about building some kind of agentic AI applications, then you better use those. Okay, so we have a bunch of things here. Those are the fields that can go into the agent. So if we have this agent here, right? Let's go, here we go. Right, so this is what can go inside of here, inside of the agent. By the way, one more thing to add here. We run it like this, right? So that you can see everything, every single part, right? So we just say run, which is a separate function from the OpenAI Agents SDK. Yeah. Again, you can use Anthropic. Anthropic follows a little bit different patterns, but they are all approximately the same. If you build something with OpenAI SDK, you will be able to use it with all the others. Okay, so this is not a big deal. You will be able to use it with all the others SDKs. They are all approximately the same. So now there are two fields that are required. Obviously, name for your agent and instructions. See, system prompt. Okay. You can make it dynamic. You can make it non-dynamic, obviously. Okay. Then this thing as a prompt. Don't confuse it with the actual instructions. So instructions is actually this system command, right? This is the system command. And this is not the prompt that you get from users, okay? This is not the thing. What you get from users, look at this. This is what you get from users, right? When you actually run the agent, then you insert inside the message from the users, okay? Not this prompt thing, okay? So this is a bit different thing. Handoffs, we're gonna speak about the handoff pattern. So for now, it's not important. Obviously, model. Now with the model, it's, if you look at this, then you can see that this is not required. Model is not required. What the hell? Why is it not required, right? So what happens if we try to execute it like this without this? Huh? What's gonna happen? Well, let's have a look. Where's my terminal? Let's have a look. Let's run it again, okay? And I'm trying to run it. Okay, and it works. And why is it working? Well, because by default, if you don't have any model, then it's gonna default to the default model, which I think it depends on the what is current default model for your account. You can set it. You can set what's the default model, because depending what kind of AI application you're developing, it's going to be a different model, right? So if you're developing whatever, some agentic stuff, then probably you want to use like 5.4 as a default one. But if you're developing some, whatever, I don't know, something with a cringe personality, then maybe you want to use 4.0, which people were crazy when it shut down, right? So I think now 4.1 is the one for people with a crazy personality. Anyway, so we had think like model settings. It's not that important. Now tools, this is important. We're gonna speak about tools a bit later, but essentially those are the tools that we already know how to use from the last time, right? When we give an agent tool, then we can use it. Now, because this is OpenAI SDK, there's a little bit more nuance to it because they're built in, there are custom tools. We'll speak about this. MCP servers. Now, you know me if you have been watching this channel for a bit that I'm not a big fan of MCP servers. So I personally, I don't use them. Like, I don't know, like, as much as I tried to love MCP servers, I just don't find that much of like real world benefits of them. Sure, there are benefits. I like, I don't doubt. I just don't think that this is any kind of game changing thing, those MCP tools. I would always prefer a CLI over an MCP tool. The problem that there is not always a CLI available, okay? But if you have a CLI, especially look at the Playwright. I showed a bunch, if you watched my Claude Code tutorial, I showed a bunch of things with the Playwright, which is essentially like a tool that allows you to do a bunch of testing and allows you to visually test everything that's going on, right? So if your agent finished doing something, you can use this Playwright. You can use Playwright to test on the actual website and see that it's actually working. Now, there is such a big difference in the speed between Playwright CLI and MCP. It is incredible. Maybe one day I'm gonna make a separate video just ranting about MCPs and how I hate them. But yeah, in general, MCPs kind of meh. Use CLIs if you can, but the problem is that everyone has MCPs now, not everyone has CLIs, unfortunately. It's gonna change. Mark my words, people are gonna start doing CLIs. Why? Because CLIs is the native language of agents, and agents understand CLIs the best. So CLI is gonna explode, I think. Okay, we have guardrails. I'm not using guardrails either. Who needs guardrails? Just let your agents do whatever they want. No, I'm kidding. I don't like the baked in OpenAI SDK guardrails. I prefer the gate system, okay? So I prefer gates and programmatic checks instead of the input and output guardrails. Just not, I don't know, just don't care about the guardrails that much. Output type, we don't care. Tool use behavior, we don't care. Result to choice, we don't care. And handoff output type warning, whatever, we don't care about them, right? So you see, there are not that many things that you can actually put into this agent, but it allows you to basically do anything you want with the agent. So that's the good thing about this. Now let's have a look at the tools, because I promised you to have a look at the tools. Now, I'm not gonna go deep into how to define tools because we already did it. Okay, we already went in and we had a look how to define tools. Now, what I wanna show you is that there is a difference between tools that are already in, right? So basically, tools in a nutshell, just to refresh in case you watched it 3 days ago, those tools. Okay, so tools allow agents to actually perform some actions, like for example, to execute bash scripts, right? To execute shell commands, and or maybe even use computer. Here, this is a good example. Like even use computer, or use a browser. There's MCP for the browsers. There's also a Chrome API that you can use. So the bunch of things, but basically tools allow your agents to do stuff. And there are obviously some tools that can be executed back on the OpenAI server. They don't have to be executed locally. For example, search, right? A search is a really good example of something that can be actually executed there on the OpenAI part, and we don't have to run it on our own. Here are the tools that are baked in that we can already use, right? So function calling, we can have web search, we can have remote MCP server. Who cares about them again? MCPs, freaking MCPs everywhere. Oh my god. Okay, we have skills, we have shell, we have computer use, we have image generation, file search, and tool search. By far the most useful one are web search, right? Because you don't want to implement the whole web search on your own. Imagine if you have a tool and then you need to implement the web search. Now that would be pain, right? No one would actually do it. So it's nice that it's immediately available there with the Agent API. Now, the thing about this, what I want to show you, what's important to understand, that it allows you to abstract away those simple tools. So if this is you or your application that you're developing, okay, so this is you, right? And this is OpenAI server. Then whenever you're gonna make a request, it's gonna actually use the tool there, right? And actually do the search, and then get the feedback, and then give you a response, right? Otherwise, if it was other way around, if they didn't have the baked in thing, then it would just use it as a tool as what we had before, and you would actually need to implement the whole freaking search, okay, which would be very annoying. So now here's example. Here's how you do it, right? And another feature is that it's incredibly simple to basically use them. So here's how we use them. We import tools immediately from this OpenAI SDK. Then we create a new agent and we just list those tools in an array. You can see, I don't know why I have here code interpreter. Why do we need for a travel assistant? What kind of travel assistant is it that want to run Python or whatever? So we only have web search tool, okay? So we don't need this code interpreter, okay? Right, and then we say medium, and then we run the agent with we ask, okay, I plan a trip to Germany. What are the top 5 attractions in Munich? So let's actually execute it. That's what built-in tools, like this. Okay, so now it's gonna actually search for the top attractions, and I'm gonna see, because I'm from Munich, so I live in Munich. I'm from Ukraine, but I do live in Munich, so I'll see if that's correct. Okay, so Deutsches Museum, good choice. English Garden, good choice. Munich Residence, not so good choice. Marienplatz, terrible choice. Okay, Nymphenburg, very good. I live nearby. Okay, so really good thing. So you see, basically this search was performed without us doing anything. Again, this is a way, this OpenAI Agent SDK is a way to abstract your application. Other tools, and one of the very cool tools is Shell. Okay, so remember when we were speaking about the agents, when we were building the agent, what we said is that bash is all you need, which is shell is all you need, or bash all you need, is the same idea. Idea is that if an agent can execute something inside, then they can already basically execute, basically do anything they want on your computer. So I have here an example of shell tools. Now, the problem with the shell tools that it comes with two different ways of using it. It comes with a local shell tool or with a cloud shell. And this one, basically, this one by default, it is local. So if we want to have a local shell execution, then you do need to provide a local execution. So it does look a little bit similar to what we had before, right? So it is kind of similar, okay? So yeah, in this case, it is not immediately clear what the hell, why do we actually need, what's the benefit, right? Because look, we have here a while loop, right? The difference here is that, again, we abstract away the tool calling. Remember, if we go back to the agents and we go where we had this, I think step number 3 or something. Yeah, here's with the tool, right? We define the tool. Now the difference is that here with the tool, we defined the schema of the tool, okay? So we have to basically tell the agent the schema, we have to tell how to run it, and then we also need to actually run the tool and provide the implementation. Now, in the case of Agent SDK, we don't need to tell the agent how the tool is going to look like, because it is already defined by the Agent SDK. So that's the benefit, okay? We have a standardized way. We don't need to standardize this whole interaction on our own. No, it's already done by OpenAI. And that's the benefit of it, right? That's why we want to do it instead of just defining our own tool. But we still need to have this whole implementation where we actually check and we actually execute the function, okay? Where was it? Here, execute bash, right? We still need to have it. I have it a little bit more fancy here in this, another one in the shell tools, right? I have it a little bit more fancy, but the principle is the same. And the benefit, if we compare it, wait, let me freeze it here. So this one, And I think step number 4, right? Yeah. So step number 4, if you look at this, you can see that we have a while loop for basically this whole tool calling thing, right? So we call the tool, and then we go through all the commands, and we do it in the loop through all the tool calling. Now that thing is already abstracted away. We don't need to have a loop for that. Okay, so basically whenever we have this thing here, just alone that we define this tool, it's already handles this whole inner loop calling thing. Okay, so we don't need to basically write another loop on our own. And still, we're gonna need to have loop for user interaction, okay? So this is obviously doesn't have anything to do with the LLMs. It's just whenever you want to have back and forth with the user, well, I'm sorry, but that's the only way to do it, loop, okay? In some sort of way. Now there's a bunch of things. I'm not gonna bother you. You don't need to read all of this. Doesn't matter, like literally doesn't matter. I just wanted to show you the tool usage. We don't care about this. But even if you look at the code, it's less than, it's like 50 lines of code, okay, 56 lines of code. So it's not a huge deal, okay? So let's have a look. Let's actually execute this. So let's execute this OpenAI built-in tools. So instead it's gonna be shell tools, okay? So here I'm gonna say, hey, can you create a demo folder and a script in there and execute it, okay? And now, see, it prints everything that it created, right? So you see it's using bash, and it did create script, okay? That's pretty cool. And now I'm gonna say delete that folder, okay? Now the demo folder is removed. Okay, so you can see basically we've built the agent that we have spent quite a lot of time building. And this is essentially the Claude Code. It is missing a bunch of things, obviously, right? But it does have memory, right? Because see what I did? I said, where is it? Yeah, I don't think it shows, here, delete that folder. Okay, so that folder, so it has the history, right? Obviously, because I programmed it in the way to have history. See, history, right? So we're saving the history. Now, you can see that we basically built Claude Code here in 56 lines of code. Of course, this is not true, but essentially, okay? This, if you understand what's going on there, that's gonna serve you well, because this is gonna be huge. This is like discovering Bitcoin in 2015, okay? And you're discovering it right freaking now. Let's exit, clear, okay? So we have this thing. Now we can also, of course, define custom tools, right? So you can say, hey, we have here a new tool, whether it's using a little bit of a different thing, it's using this Z objects. Again, the same idea, we need to pass a schema into the API, okay, in form of the Z object, and then the agent is going to be able to use all of that, right? So for example here, what's the message? The message, what is the weather in Munich and Kiev right now? So let's execute this thing. Custom tools. Let's go. Okay, and says Kiev 11 degrees, Munich 8, partly cloudy. Now, the reason why I don't want to go deep into this is because you just need to know that you can do 3 things. You can use the built-in tools whenever you just don't want to reinvent the wheel. Yeah, wheel. I think that's the way you say it. Okay, whenever you don't want to reinvent the wheel, you use the built-in tools. And whenever you can, you should use the built-in tools. Okay? Now, you use the built-in tools. Then, you can also use the custom tools that you define. That's it. That's the things. That's all you need to know about the tools. And again, we defined the tools before so that you understand how those agents work when we just make LLM requests. Now we are using the Agent SDK, the thing that OpenAI already defined for you. Okay, in case you wonder why I said Salesforce, because I'm freaking a Salesforce developer. I see Salesforce everywhere. In addition to this, we have interesting things which we're gonna discuss a little bit more in detail. Okay, we covered this hosted OpenAI tools, right? Search, web search, file search, code execution, image generation, blah blah blah. Tool search, also pretty cool one. Now we also covered this one, built-in execution tools, okay? Function tool, so basically this is the way where you can define the schema, okay? JSON schema. Remember JSON schema? I hope you do. Okay, so that's what we already have. Now, MCP servers, again, as I said, I hate them, I don't care about them, okay? Experimental Codex tool, not a good at of this moment of recording of the video, we don't care about them, but agent as tools is pretty cool thing, okay? Agents as tools, this is what we gonna be covering. But first, we need to cover the agent orchestration, okay? So agent orchestration is an interesting thing. It has kind of two main patterns. It has the agent as tool and then handoffs. Now, the idea behind agent orchestration, and I think, in my opinion, I might be hyping up a little bit too much for a developer video, but let me know if you agree with me. I think that this is going to be defining thing of 2026. 2026 and maybe even going forward, because I think that the number of agents that are browsing internet, that are basically everywhere in the world, the number of agents will grow exponentially. And right now, the way I write software, when I'm not teaching you, the way I write code is that I am orchestrating agents, okay? I'm not writing code anymore in the way that I'm just typing everything manually. That's stupid, okay, at this point. I am orchestrating agents, and I think that those patterns of orchestrating agents are going to be even more important. I think the biggest breakthrough of 2026 should be a really nice framework of orchestrating a lot of agents. This is my opinion. Again, you don't need to subscribe to this opinion, but I think that this is the way we're gonna go from now on. So, it's important to learn those things. Agent as tools is incredibly simple. Okay, it's incredibly simple. Let me show you. First, let me show you with the code. Okay, so we're gonna go. So we're done with the tools. We go to the patterns. Agent as a tool. Incredibly simple. And you know why is it so simple? Because hopefully you learned those AI workflows. If you remember those AI workflows that we covered, and I said it is important to understand them because it's important to understand freaking agents. Now, if you understood them, you will understand this, okay? You will understand it in seconds. Okay, here's example. I have one agent who is a code reviewer, okay? You are a strict code reviewer. You're the 10x software engineer, okay? Review the code and receive and give a concrete feedback on quality, bugs, and blah, blah, blah. I have another agent, which is doc writer, someone who specializes on writing docs. And again, why do we do it? Because we do the context window management. Every agent, whenever you have 2 different agents, 3, 5 different agents, is a separate context window. Okay, so you should not think about them as people, even though I give here example a little bit like, okay, we are working with people, but you should think about them as context windows. If you had an agent that has 1 trillion of a context window, well, maybe you don't need those things. But right now, as of moment of recording of this video, this is important. It's important to have multiple different agents. And I think it's going to be important for next 5-10 years. You just cannot have an agent that can be a robotic or whatever, like a Tesla robotic humanoid agent, and at the same time going to be like a coder in Scala or Haskell. Like, I don't think that those are the same agents. I think we're gonna have specialized agents. I don't think we're gonna have like general purpose agent that just do everything. So we have one agent that does the code review. We have another one that writes docs, and we have a manager. Okay, and this manager will delegate to the specialists. Kind of sounds a little bit like humans. Okay, don't confuse it. Don't confuse it. Agents are not freaking humans. It's just a stupid example, okay? Agents are not humans. You should not impose your thinking about them, uh, about just context windows as if they are humans and give them human roles. In this case, we do it, but it's just for the learning purpose, okay? Now, here you have the engineering manager, and this engineering manager, it has two tools, code review and write doc, okay? And you can see that we take the agent, the code reviewer, and we put this code reviewer as a tool to this general purpose agent. And we do the same with the doc writer. And then we have our prompt, and then we just write it in the file, right? So let me write it. So npm run, and what do we run? We run agent as a tool. Yeah, this one, okay? So we are running this, and there's gonna be not a bunch of interesting stuff happening. And by the way, I'm using my credits all the time when I'm running all this. So maybe if you want to join my next cohort, so I can pay for OpenAI credits and I can keep teaching you. There's a reason why this video is OpenAI, because they're cheap models. Okay, they have cheap models. If I were to record this video with Anthropic, I would already go bankrupt. Okay, so if you want to join my next cohort where I'm gonna teach you more about this whole AI thing for developers, then links inside of the description. Go join my email list. I'm writing almost every day about cool AI things. I think you're gonna have a lot of fun if you enjoyed this tutorial. Anyway, so we're going back, and you can see here that we have a review. Okay, we have a review, we have issues, we have whatever documentation, blah 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 blah. Now if we visualize this pattern, then it's gonna look incredibly similar to what we had before. We have the first agent, then this agent hands off, distributes work into two different agents, then they produce some kind of output. Let me take another color, some kind of output, and feed back into this agent. Okay, and then this agent combines all of that. Does it remind you something? Let's go back, all the way back here. Where is it? Orchestrator-worker. Well, isn't it the same thing? It's just that now, instead of this synthesizer, we have an agent here. We have an agent, and then instead of those LLM calls, we have other agents, and they just send back the information to the main agent. Again, now here, we are making semi kind of automated things, because those agents on themselves, they do have the agency, right? They have the freedom. Those agents inside, they're not deterministic as our programs used to be before the whole AI thing. But I forgot what I want to say. We're not gonna cut it out. Anyway, the point is that they feed back into this main AI agent. Anyway. Okay, so you can see that then it combines, and then it's out once everything is combined. So this is what we call agent as a tool, right? This is very important, so we can use those agents as tools themselves. And now this is what I was talking about. Now we can look at our application as basically a bunch of nodes, right? A bunch of nodes like this, right? And each node here is an agent. And then we have a combination and interactions between them, which is an incredible, interesting concept. And that's why we have frameworks to manage all that. We don't need it right now. But anyway. So you can see it's very simple. It's very, very simple. Now, the next thing that we have is the agent handoff. And when you look at this, it's going to be incredibly similar, okay? Now, we have a billing specialist. Does it remind you something? Then we have a technical support. Then we have the triage agent. Agent that basically says, where should we go? Now, the task of this triage agent is basically to understand where the user request goes. Does it go to the billing agent or does it go to the tech support? Let's go back. Let's go back. Let's go back here to the routing and then to the orchestration. Okay, so you can see that. Let's first speak about the routing. Very similar thing. We get a message. We distribute it to see what kind of LLM call do we have. Now the difference is that again, the node just turns from an LLM call to an agent. And that's the whole difference. But the patterns are the same. And this is why I'm so excited about this. This is why I always tell you that you need to understand the basics, you need to understand the fundamentals, right? Because if you watched carefully those routing patterns and if you implement it yourself, you will absolutely have no issue understanding what the hell is this pattern here, right? So, let's have a look. We have main agent. Now, we get some kind of message. Let's say you're building ticket support, right? You're building the ticket support. We get the request. It goes to the main agent. Then this main agent actually thinks and maybe actually does something, right? So in comparison to the just simple LLM calls, now this is an actual agent. So the actual agent can actually go and do a bunch of things. Now after that, it hands off to the billing agent or to the tech support or to another agent, whatever. It doesn't really matter. Yeah. And then we are out, or we are going back, or maybe we have some kind of gate in between, right? Again, you can combine them as you want, but in this case, in this particular case, we're just out immediately. So basically, this triage agent, the whole idea behind this agent is that it doesn't really do a bunch, and it only interacts for the first time with the person. It's like a waiter when you come in and like someone in the like very nice hotel and they greet you and this is the hair, and they say hi, welcome to our hotel, right? And then you never interact with them again. You just interact with I don't know, some lady on the reception, but that's the agent, right? All right, a bunch of examples, weird examples. Okay, so here's example, right? Someone is sending a message. I'm getting 500 error when I try to upload a file through API. It was working yesterday. Okay, so let's run it. Handoff. Okay, now you'll see that it will forward to the tech support agent. And now we're kind of getting forward to the actual person, right? To the actual agent. And then we also speak basically all the time to the tech support. Why is it thinking so long? What the hell? Okay. It was weird. Why was it so long? Okay, where is it? Okay, so handled by tech support agent, right? Now, if we say that there was some billing issue, I'm getting refund, but I don't want to. Why is this happening? How to stop it? Wow, that's some brutal stuff here from Copilot suggestions. Okay, handled by billing agent. Now, see that we are not interacting back to this agent. It's fine. I don't want to like implement the full live system here, but essentially you can see that we are handing off this thing. And we have a nice parameter here. I haven't showed you like the main thing, that it's that easy as just literally one line of code. So we're handing off this thing into the billing agent and to the tech agent. And that's it. It's that easy to implement. You define one agent, you define second agent, you define third agent, and you say in the third agent, okay, you just need to reason, and then you need to hand off to another agent. That easy, okay? It's very, very easy. Okay, so this is an important one. Why is it important? If you want to have any shot of developing like or using AI agents for any kind of live application, you need to be careful with all these things like we talked about, like gates and all this type of things. But for this is important, okay? Now, let me first show you how it looks like, okay? So you understand what exactly I mean. And it's called human in the loop, like this, okay? Now, you can see that we started running something, and then we want to refund the person. And then we are asking, approve or not. So see, we are interrupting the loop and asking the person if we should actually execute this thing. Very important. This is what Claude Code does all the time, right? You try to run Claude Code to do anything, and then it's gonna, oh, can I execute this command? Can I execute this command? Can I execute that? Blah, 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 right? So here you can see that we can say yes. And then it's gonna actually go and do the order, right? So this is how it looks like. Human in the loop. Again, we're gonna need to have a loop for that, right? It's even called human in the loop. Okay, so we have a bunch of things. So we have safe tools, we have a dangerous tool, right? Then we have the actual agent with the tools, with the one tool, with another tool, and then we run the agent and we say, okay, let's say the message is like this, and then what we can get back are interruptions, right? So this is the whole idea behind this human in the loop is the interruption. And again, the same thing, the same way as when we had tools to call, we get interruptions. And as long as we have those interruptions, we're gonna keep asking the user, okay, that you need to have an approval. And if you, and then when we have this interruption, okay, we send it, and then we ask, okay, do we approve it? And then we either approve or reject it, right, as a typical promise, okay? And then we resume the agent. So again, very simple, but again, if we look at this, what happens is that we have an agent, we look up an order, and then if we know that this order is safe here, then we just can execute this thing and we are done, right? But if we know that there's some kind of action that is actually kind of a little bit trickier, like for example, if we are running rm command, right? If your agent is trying to delete something, then you're like, wait, let me actually ask the user if you actually want to have all your files on your file system deleted or not. Are you sure you want to delete all your files? Are you sure you want to delete your database? Better ask, right? So then the agent thinks, okay, we actually need to ask this thing, and then we interrupt this, and then we wait for the human review. And the way we do this whole approval is so simple. By default, the agent is not gonna send you any interruptions, but you need to add this one thing, needs approval to the tool. This one thing you add it to the tool, and then your agent gonna send you when it thinks that it needs approval, okay? It's gonna send you, okay, not when it thinks that it needs approval. Whenever it uses this tool, it's gonna send you the interruption, okay? And then you can pause and you can ask the user for it. Okay, and you can, of course, you can also build a system around it, right? You can build a system where you know that certain things, okay, maybe we can have another layer on top of that. Maybe we have another reasoning model that will verify if it needs to be approved. This is something that people experiment now, and I think they're gonna do it pretty soon in Claude Code, that you have one reasoning layer and then you have another reasoning layer, and they're gonna kind of view each other, and they like one LLM is gonna basically, one agent is gonna approve the changes for you. This is, I'm pretty sure it's gonna come very soon. I know where I saw it that it's coming, but it should be coming. It makes sense. That's it. Those are the freaking agents. I hope that you enjoyed it a lot. I think that agents will be by far the biggest economic growth of this century, of my lifetime. I think that those 2-3 hours that you have spent with me by learning those, it will pay you off 100 times, because understanding agents now is like understanding Bitcoin in 2012. Okay, so go revisit any chapter you want. If you have any suggestions on what kind of video do you want to see, then write in the comments. If you like the video, then please comment. That helps YouTube a lot, and I would really appreciate it. If you want to know and learn more from me, then join my email list. I write for free every couple of days about AI. Yeah, thank you so much. See you in another one.